Okay guys, let's quickly just warm up with something here. I just want to see if you guys know what you know. I want to see if you know what you know. Come on, let's play this. Let's play this. And I will see if you guys know what you know. Okay. So this is taken from the Mind Action Series textbook. And so you can see that at the top we have an example, all right, where they say -4. Okay, this is just to warm up before I transition into something else. Okay, so wait. So we need to know about the number system. So we've got natural numbers, all right. Remember, natural numbers are numbers that start at 1, increase by 1 all the way to infinity. That's the symbol we use for natural numbers. We have whole numbers. Okay, the symbol for whole numbers that start at 0, increase by 1 to infinity. We have integers. This is the symbol for integers. Numbers that are whole numbers, meaning they start from 0, increase by 1 to infinity. So it's both positive whole numbers and negative whole numbers. In other words, from 0, it decrease by 1 all the way to negative infinity. Those are integer values. Rational numbers, these are numbers that can be written as a fraction of integers, top and bottom, but the denominator cannot be 0. When you look at their decimals, recurring decimals, and you can have terminating decimals, meaning decimals that are rounded off. Here we have irrational numbers. Okay, irrational numbers are the opposite of rational. So if a number is irrational, it cannot be rational. A real number is a number that is contained within the number system. So basically all these numbers, natural, whole, integer, rational, irrational, these are all part of the real number system. And I wish to add one last column here, which is not noted here, and that is an R for real number with an apostrophe. This means non-real. So we have non-real, we have real, we have irrational, this is rational, we have integer, we have whole number, and lastly we have natural. Unfortunately, later I won't be doing any trigonometry today. I'm not doing any paper 2 stuff today. I said I am reserving paper 2 stuff for tomorrow because there are people writing paper 1 tomorrow. And so if I'm going to focus on trigonometry, that will not serve the purpose and the intention of this live lesson. So if you unfortunately in your province are writing paper 2 tomorrow, unfortunately, I'm sorry, I will not be touching on any paper 2 related stuff unless I can see that there's a reasonable number of people that are like, please do that. So if we are going to now characterize or identify -4, this is an example. Okay, and unless you can tell me when are you writing trigonometry or paper 2? All right, are you writing it tomorrow? If you are, then maybe I might fit it in. Okay, well, we'll set aside some time, but it will have to be much later. Okay, because I'm trying to cater for those that are writing paper 1 tomorrow. Grade 10. This is grade 10, guys. So if you are in any other grade, just take note, grade 10 here. So -4, is it a natural number? No. Why? Because numbers that are natural are numbers that start at 1. They increase by 1 all the way to infinity. Sorry guys, I just want to reshare this with Okay. Okay, so as I was saying, negative 4 is a natural number. Rightfully so it is. Because it's a number that starts at 1. No, sorry. Negative 4 is not a natural number. Can't be, because natural numbers are numbers that start at 1 and increase by 1. So negative 4, no. Is negative 4 a whole number? No, because whole numbers start at 0, increase by 1, all the way to infinity. So that does not fall in this family. Are they integers? Negative 4, is it an integer? Yes, because integers are positive and negative whole numbers. 0, 1, 2, 3, 4, 5, 6, we are increasing in 1 to infinity. We go back from 0, negative 1, negative 2, negative 3, we are decreasing in 1. Those are the family of integer values. So does negative 4 qualify? Yes. Rational. Is negative 4 a rational number? Yes, because negative 4 can be written as negative 4 over 1, which a rational number is a fraction of 2 integers. So it makes sense that negative 4 is rational. Is negative 4 irrational? No ways. Because remember, if a number is rational, it can never be irrational, because rational and irrational numbers are opposites. Next, is negative 4 a real number? Yes, because real numbers are all the numbers in the number system. And then lastly, is negative 4 a non-real number? And the answer there would be no, because non-real numbers are all the numbers that can be written inside a root that is even, and there's a negative number inside that root. All numbers that are inside a even root that are negative, we regard them as non-real. I repeat, all negative numbers found inside a even root are non-real. Okay, so negative 4 is not a non-real number. Now I'm going to test you guys. Let's go down here. I'm going to do this for just for the first 15 minutes of the live lesson, so please entertain me here. Let's go. Cube root of 64. Is it a natural number? Yes or no? Please, guys, comment section, just say yes or no. Cube root of 64, is it a natural number? Sbuda says yes. Sbuda says yes. Supernot Angel says yes. Lesejo says yes. Okay, I think those 3 yeses are sufficient. Guys, cube root of 64, yes. So most of you are saying yes. Cube root of 64, remember, if you evaluate what the cube root of 64 is, it is equal to 4 when you simplify it. So is the number 4, which is the cube root of 64, a natural number? You guys are 100% correct. Yes. Let's move on. Cube root of 64, is it a whole number? Yes or no? Is cube root of 64 a whole number? Okay, so Buddha says yes. Yeah, Lesefo says yes. Remember, guys, I'm just warming up here. Super not anything yes. Big Q saying yes. So you guys in the majority are saying yes. You guys are 100% correct. The answer is yes, because whole numbers that start at 0 increase by 1 to infinity. So 4 is definitely in there. 4. Cube root of 64, is it an integer value? Yes or no? Cube root of 64, is it a integer value? Remember, this symbol stands for integer. So Buddha says yes. Okay, Lesefo says yes. So we've got a few of you saying yes. In fact, the whole majority are saying yes, and you guys are 100% correct. The answer is yes. I don't want to stay too long, guys. Okay. Cube root of 64, is it a rational number? Yes or no? Cube root of 64, is it a rational number? Okay, so Buddha saying yes. So Buddha is very fast, eh? It's fast with the types. Big Q saying yes, coming in at number 2. Angela saying yes at number 4. Let's say coming in at number 5, and then Supernova Angel coming in at number 6. And I can just say yes, guys. Cube root of 64, which is 4, is indeed a rational number. Let's go on. Cube root of 64, is it a irrational number? According to the symbol, is it irrational? Cube root of 64, is it an irrational number? Yes or no? Okay, PQ saying no, Buddha saying no, Supernal Amy saying no, Angela saying no. And of course, it's a big fat no. You guys are 100% correct. Very good. And then last but not least, no, second last, is cube root of 64 a real number? Is cube root of 64 a real number? Yes, Buddha. Yes, Supernal Angel. Yes, Funk. Yes. Okay. All right. Then last, is cube root of 64 a non-real number? Is it a non-real number? Okay, we're saying definitely no. All right, you guys get the point. I'm so proud of you. I think like in the comment section, a flawless way of identification of numbers where cube root of 64 was concerned. Let's check out the next number and see if the flawless run will continue. We have negative square root of 49. The negative is outside the square root and then 49 is inside. Is the negative square root of 49 natural? Yes or no? Natural number, this one? So Buddha saying no. Coming in at number 1. Supernal Angel coming in number 2. Prude Keen is coming in at number 3 saying no. Lesenho saying no. Supernal Angel no. Funk saying yes. Do I see someone saying is the negative multiplied or? That's a good question. One, you have to answer yourself and then give an answer. Big Q, don't ask me questions, give me answers. Junior Punk saying no. Don't ask me questions, give me answers, my guy. Because at this stage, if you're writing an exam, you'd have to give the answer. There's no time to ask questions there. In the exam, you need to be sure about what you are seeing and then be able to interpret it correctly so that you can give the correct answer. So you should be telling me. All right. Guys, the negative is obviously outside. It's multiplied to the root. I mean, that's the attachment of negative to the square root. Okay. Yeah, so that question really is one that you should be able to answer yourself. Is it natural? No. Okay. Is it a whole number? Cube root of 64. Square root of negatives. Negative, the square root of 49. Is it whole? Is it a whole number, guys? Yes or no? Prude Kinney saying no. Junior PK saying no. BQ saying no. Okay, majority of you are saying no. Integer, because it is definitely not a whole number. Integer, is Buddha saying yes. BQ saying yes. Supernal Angel saying yes. That's all saying yes. All right. Okay, we agree. It is an integer, guys. Positive and negative whole number, that definitely qualifies, because remember, this is actually equal to -7. That's what it is. That's the answer we get when simplified. Is it a rational number? Is it a rational number? Is it a rational number? Funk saying yes. BQ saying yes. Buddha saying yes. Super saying yes. Okay, definitely is. All right, because remember, the answer, which is -7, can be written as -7/1, and we know that that's rational. Is it an irrational number? Is it irrational? Okay, Junior PK saying no. Buddha saying no. BQ saying no. Okay, the first three are enough. No, definitely indeed. Is it a real number? The negative of square root 49. Buddha saying yes, it's real. Junior PK saying yes, it's real. Prudy Kitty saying no. BQ saying yes. Okay, guys, this here, okay, remember the negative sign is not inside, it's outside. So we can evaluate the square root of 49, get 7. Then the negative sign multiplied with that 7 gives you negative 7. So that's a real number. Okay, so it's definitely real. Is it non-real? Is it non-real? Definitely no. Thank you. All right. All right. Now, guys, all right, 5 pi over 9 pi. 5 pi over 9 pi, is that a natural number? Okay. When all is lost, guys, your calculator can also help you if you like feeling pretty stuck. 5 pi over 9 pi is my question to you. What is it, a natural number? Five pi over 9 pi. So the people in the comment section are saying no, no, no. Yes, it definitely is no. 5 pi over 9 pi, is it a whole number though? Okay, we're having no's all around. Is it an integer value, 5 pi over 9 pi? Is it an integer value? Okay, let's say for again saying no, Sbuda saying no, Big Q saying no. All right, so we are all saying no. Is it a rational number? 5 pi over 9 pi. Is it a rational number? Is it a rational number? Let's say for saying yes, Big Q saying yes, Supernal Angel saying yes. Yeah, guys, if we go to the calculator, if you put in 5 pi over 9 pi, look at that. 5 pi over 9 pi gives you 5 over 9. Guessing it's because the pi and the pi, they cancel each other. You're left with 5 over 9. And remember, what is a rational number? A number that can be written in the form of a over b, where a and b are integers, and where b, the denominator, cannot be 0. So this qualifies. And I'm sure if you actually press SD, what's 5 over 9? It's not comma 5 repeating. Remember the 6, the calculator, because it ends there, rounds off your last value, giving you a terminating value, but this is a recurring decimal that continues forever. So this is a recurring decimal, and that qualifies as rational. So this is rational. Yes, indeed, rational. Is it irrational? 5 pi over 9 pi? Is it irrational? Okay, Sbuda, definitely no. Okay, I agree with you, Sbuda. Lesejo and not angel. Thank you so much. Then lastly, real. PQ, I see you there. Is it a real number, guys? 5 pi over 9 pi, is that a real number? Yes, it is. Definitely. No doubt. And then lastly, is it non-real? Is it non-real? Is it non-real? Okay. Definitely no. Okay, guys, that was just something to get you all gung-ho started. I just want to do one last one, okay? Because I'm interested to see what you guys are going to say here. Number 5, here we have the square root of negative 16. First question I want to ask, is this natural? Is this a natural number? Is square root of negative 16? No, don't worry. Is it a natural number? PQ saying no, Lechsejo is saying no, Supernal Angel saying no. So yes, definitely not. Is the square root of negative 16 a whole number? Is it a whole number though? Square root of negative 16. Is it a whole number? Okay, guys are saying no again in numbers in the comment section. Very good. Yeah, that's true. Is square root of negative 16 an integer value though? Is this an integer value though? So Buddha saying no, Supernal Angel saying no, PQ saying no, Lesejo saying no, Princess. Okay, majority saying no, and the majority is right in this situation. Is the square root of negative 16 a rational number though? Is it a rational number though? Okay, be very careful about this one. Buddha saying no. Lesejo saying no. Princess Kanye saying no. Princess non Super non saying no. Okay, guys, square root of negative 16 is actually not a rational number. So if it's not a rational number, is it an irrational number though? Square root of negative 16. Could it be irrational, guys? Square root of negative 16. Is it irrational though? It's Buddha saying no, super not Indian, so no. Funk saying yes. Oh, Funk. Oh, Funk. Oh, Funk. You flunked this one. All right, so guys, it's a no still. Okay, it's not rational, it's not irrational. Lastly, is the square root of negative 16 a real number though? Is it a real number though? Is it part of the real number system? So Buddha saying no, Super not Indian, so no. Fang saying no, Princess Kanye saying no. Okay. No. Is it a non-real number though? Is it a non-real number though? Do we say it's a non-real? Ghost saying yes. Buddha saying yes. Lesejo saying yes. Finally, someone saying yes. You guys have been saying no all the way, except Funk in that one situation. And you guys are 100% correct. It is a definite, absolute yes. You guys are amazing. Okay, so all of us know and understand that the square root of any negative number, or guys, if it's any even root number, that is here, even root. If it's an even root and there's a negative number inside, it's non-real. We don't even joke around. Okay, let's move. I want to come down here. Here, not comma 3, 5. Let me just ask this. What two categories, write down, what two categories does not comma 3 with a dot on top of 3 and 5 fall under from the numbers that we have identified? Can you write down the categories that not comma 3 with a dot on top of the 3 and a dot on top of the 5? Which numbers does it fall under here? Okay. So Super Not Angel says a rational number. Lesejo says rational and real. Okay. So Buddha says rational and real. Pichu says rational and real. Guys, it's very important that you are able to identify the categories that a specific number falls under. So, okay, those who said rational and real, 100% correct. So we'd say no everywhere, except say yes where we are rational and where we are real. Who's this? So Buddha is saying, let's say Howena, you're smart. No, she's very smart. You can say that again. That's one person that I can say we've been, she knows we've been on this one. We've been on this one since day one. Like she's been a Mets gamer. Like, you know, if you talk about Mets gamer extraordinaire, since like when I started this Mets is a Game TikTok page and started doing live lessons, and she was in sweet grade 8 at the time, end of the year, grade 8. She knows, all right, and she was joining in the holiday lessons that I would have during December, and just a phenomenal young lady, you know. Great things coming up there. Okay, anyways, I want to just check one last one before I call it quits. Let's come here, just here, 2 pi over 0. I want you guys to let me know, in which category would this number fall under? 2 pi over 0. You guys saw the categories that are here: natural, whole, integer, rational, irrational, real, non-real. Is there a category where this would fall under? And which one is it? Please indicate in the comment section. We're talking about 13, 2 pi over 0. In the categories listed, is there a category where this number would fall under? So let's say we're saying undefined in her comment. All right. And I guess what I want to ask is that in this statement of saying undefined, is there a specific category here? Natural, whole, integer, rational, irrational, real, non-real. Percy says irrational. Funk says none. Okay, let's analyze. 2 pi over 0. Guys, 2 pi over 0. So Buddha says you can't divide by 0. There's no category that it falls under. Guys, you're smart people in this life, I'm telling you. People that know their stuff. So yes, guys, you guys are 100% correct. Okay, firstly, we start off by Lesejo's comment. Lesejo's comment is saying undefined. And that's exactly what we say about this number. Undefined. That's all we say. Your calculator may give you maths error, but don't ever think because division by 0 gives you maths error. You see, like for instance, we can just see the display. 2 pi over 0, we get maths error. This maths error means undefined. Division by 0 is undefined. Like dear old Lesejo, dear amazing Lesejo has said, Funk says none of the categories in the listed categories, and Funk is 100% correct. Okay, yeah. And what Smuda says, you can't divide by 0. There is no category that it falls under. 100% correct. Percy, we can't say that 2 pi over 0 is undefined. I understand why you said irrational, because you are seeing 2 pi. If it was just 2 pi alone, yes, we would say the number is irrational. The minute you divide by 0, you are talking about undefined, and therefore the category is none of the listed above. Okay, right, guys, I'm just touching on a few things here. Okay, if they say represent the following on a number line, let's look at this. Number 1, do we know how to represent this on a number line, guys? Are we all clear and clued up about how we represent x? We read this as this is what we call set builder notation. Okay, we all know how to represent that on a number line. Okay, I hope so. Percy says yes, unequivocally. Percy's like, yes, definitely, sir. Know how to represent this on a number line. You don't need to ask me twice. You don't have to share it with me twice. All right. Okay, I'm glad. If that is the case, we're very happy that you can do that, because I expect everyone in this live lesson to be able to represent answers on a number line if you are given, something in set builder notation. So, depending on which, okay, when we say x is greater than 6 on the number line, we know if 6 is here, then we have 7 there. Okay, x greater than 6 means x is bigger than 6. X is bigger than 6. That means numbers that are bigger than 6 lie on which side of 6? On this side of 6. But we are also told that x is an element of integers, and we know that integer values are numbers that are positive and negative whole numbers that increase and decrease by 1. So we are not going to include 6, but we can go ahead and have a shaded dot above 7, have a shaded dot above 8, because this is an indication of the skip for integers. Have a shaded dot above 9. And then we can just have a nice little untouched arrow to indicate that this pattern of jumping up in ones for integer values where x is greater than 6, that's a true representation on the number line of the answer. Now the Mind Action Series textbook, the new one, does this, okay, whereas the old Mind Action Series textbook, 6, 7, the dots are on the numbers. 6, not included, of course. We just say 6, 7, we dot 7 and 8. Then we could dot 9, and then what we do is we draw a vertical line above the 9, and then we draw an arrow to just indicate that this pattern of integer values greater than negative 6. Remember, they said x is greater than negative 6. So we cannot represent, guys, the values uh, including 6. We only include the values 7, at least show that 7 would be included, because the numbers that are greater than 6 that are integer values are 7, 8, 9, and there's more to infinity, of course. So this vertical horizontal arrow is to showcase that this pattern continues of integer values all the way to infinity. So these are two viable ways that you can write this in this set builder notation in number line format. So there's this way, okay, and of course your number line here is there, your number line is there. Okay, so you have two represented way. New mind action series does this, the old mind action series does that, and I think either way you would be marked 100% correct if you represented this on the number line. Okay, I don't know if you guys have any questions, right? Or if you'd like me to do any other problem here to represent it on a number line. Okay, let's look at this one. X such that x is greater than or equal to negative 4, but less than 1, where x is an element of real numbers. Now remember, integers are basically just the negative and positive whole numbers. They increase and decrease by 1. Real numbers, on the other hand, include all the numbers in the what? In the number system. But specifically here, our restriction is saying we're looking at numbers between negative 4, where negative 4 is included, to positive 1, where 1 is not included. But this is for real numbers. So then, of course, if we go to our number line, what do? We can just simply draw a number line, write our smallest value on the left-hand side of the number line, which is negative 4. Biggest value on the right-hand side of the number line, which is 1. Then remember, what did they say in the restriction? They said x is greater than or equal to negative 4. So what does that mean? It means we are going to include negative 4. So what we are going to do above that 4, we are going to shade 4. But then, since 1 is not included, we are going to have an open dot. We then connect these dots. Why do we connect the dots? It's because that is to account for every real number in between negative 4 and 1. We are saying every other real number, meaning rational and irrational numbers that are found between negative 4 and 1, are also part of our representation of the numbers we need to have. So that's basically how we attend to questions of this nature, right? And we are able to represent them correctly. Okay, I hope that makes sense, and I hope you guys can see that very clearly. Okay. Okay, if we look at another one here, okay. Okay, so if we look at another one here, just one more. Let's say we're looking at okay, so this would be the same. I mean, this would be the same here as well. X is an element of real numbers. That means we connect the dots. Okay, but in this case, x is less than or equal to negative 4. X is less than or equal to negative 4. Look at the number system. X is an element of real numbers. So this one, okay, I just want to show you here. X less than or equal.
Kuphuka lapho Rasta. Slepe. Uyifakele slepe le ngoma le mfana.
Le? Ayazi abazulu ngibakela zona.
Okay.
Yours are one kunjani?
If
Ngisakhuluma.
So as I was saying, guys, x less than or equal to -6. You have your -6 there. Now we are saying less than or equal to -6. Remember, numbers that are less than -6 are numbers that are on this side. But since it's less than or equal, it means we are going to include -6. Then numbers that are less than are on that side. The reason why we draw the arrow from the dot is because we are told that x is an element of real numbers. So that means we want to include all the numbers from -6 all the way to -infinity. This arrow from the dot is to represent all those numbers, right? Every single number imaginable that you can think about that comes before -6, that would be included as part of our answer as well. Okay, so I hope that's clear for you all, guys, right? And then let me just do one more, guys. X is an element of, let's just say x is an element of square bracket 2 to 8. If we are going to represent on a number line, what do? X is an element 2, 8. Okay, now guys, whenever we see an interval, this is read as from 2, where 2 is included, square brackets means included, and then this means to 8. This semicolon means to 8, where 8 is not included. So that's why we have an open bracket. 2 with a square bracket means 2 is included. 8 with an open bracket means 8 is not included. So we say shaded for square bracket, open dot for open bracket. Then we connect, because an interval notation is always a real number set. Okay, all interval notations are a real number set unless they may somehow stipulate something of a restriction, of a number system. But we take all, you see, all of these intervals notations would be real number sets, all of them. So let's check, for instance, even this one. X is an element -infinity to 2. -infinity, where are we coming from? So what we can do here is just simply do this. We write down 2. When they say -infinity, we look at 2. 2 is what? Included. So we shade above 2. Then we draw the arrow this side, because that indicates from -infinity to 2. We don't have to write the symbol of -infinity somewhere and then to 2. No. Here, guys, remember, this means negative infinity is coming all the way from this negative side, all the way to 2. 2 is included. That arrow is fine, all right, to basic, because the symbol -infinity is not an actual representation of a number. Infinity is just a concept in maths that shows numbers go on in a negative direction forever. Okay, that's just to indicate that. If we look at this one, -3 to infinity. Okay, different story. -3 to infinity, we say -3. You can see that the -3 is included, square bracket, so we shade it, and then we draw the arrow this side. Okay. Now, guys, those are not the only. I'm just trying to get through, that part, because I almost feel that sometimes this is an area that is overlooked for numbers. Okay, it's an area that's overlooked. Okay. area often overlooked. Just want to look at something else here. Okay, look at this one. Write the set represented on each number line below in set builder notation. Now we need to take this and write it in set builder notation. So let's look at this quickly. Starting from starting from 4 is included. 4, 5, 6, then that arrow. But it's like an arrow that is not connected to the dot. Okay, so new mind action series basically does it this way. But remember, the dots that are not connected indicate what? What number system has positive whole numbers? So I mean, I'm well within my rights to say this is a representation of what? Whole numbers. Okay, I could also say this is a representation of what? Natural numbers. I could also as well say this is a representation of what? Integer values. So I think there where we have our number system, because remember, set builder notation, all right, set builder has 3 parts to it. It has firstly the identification, so you write curly brackets firstly. It has the identification of the variable. That's the first thing. So here is the variable. After you write x such that, you then have the restriction from where to where. So for instance here, we can see 4, 5, 6. So I could actually write this as x greater than or equal. Now I would say to 4. I nearly said to 5. The thing is, why am I saying x is greater than or equal to 4? It's because the 4 is included. Then we jump 5, 6. Maybe someone else could even say x is greater than 3. That person would be well in their rights, because 3 is not included. But what is included? 4, 5, and 6. So if I say x greater than or equal to 4, say x greater than 4, greater than 3, that's fine. Where what? Now your number system. Now I think I have the option of either saying x is an element of integers. If I did, I wouldn't be wrong. Or I could say x is an element of whole numbers. Okay, if I did, I wouldn't be wrong. Or if I wanted to, I could say x is an element of natural numbers. Why can all of these 3 be satisfactory in identifying the number system? Guys, you choose one, you don't choose all of them. I am just suggesting that there are varied options of answers that would have to be accepted by the person who's marking you, because set builder notation for this specific number line, 4, 5, 6, with 4, 5, 6 included, we're obviously jumping by 1, and these are the numbers that qualify for such: integer values, whole numbers, natural numbers. They start at 1, natural numbers, increase by 1 to infinity. He starts at 0, increases by 1 to infinity. This one has whole numbers that are positive, then you have your negative numbers, negative 1, negative 2, negative 3, all the way to infinity as you decrease by 1. So I'm saying that you could write your answer just simply as that alone, okay, with the curly bracket at the end. Or you could write your answer as that alone, x such that x is greater than or equal to 4, where x is an element of whole numbers. Or you could write your answer as this one, x such that x is greater than or equal to 4, where x is an element of natural number. Or you could say, forget about x greater than or equal to 4, you could say x such that x is greater than 3, x is an element of integers, or x is an element of whole numbers, or x is an element of natural numbers. Set builder notation goes down as such. And I think all examiners know if they mark you, they would have to accommodate a acceptable answer if you so present one that is acceptable. Okay, look at this one. -5 shaded above -5 for the next negative number that is before, that is smaller and smaller. So we are going smaller and smaller, we're going towards negative who? Negative infinity. These are what kind of values? Now, of course, negative whole numbers. These are basically only can be integers. So we can write that. Okay, I just want us to check this out. We can write that as x, okay, such that, okay, let's go re-look at it again there. We said we can write that as x such that, now let's reappear again, -5, x is less than -5. So we say x is less than -5, but we are also going to say less than and equal to -5. And then the only real thing we can say where x is an element of integers. This time round, we can't say x is an element of whole numbers because we are on the negative number side. And these negative numbers can only be accommodating the number system of integer values, numbers that increase and decrease by 1. Okay, so we can say x is less than or equal to -5. I think the other restriction we could write is saying x is less than -4. This would also be acceptable, x less than -4, but because -4 would not be included as a previous value, but then all the other integer values that come before -4 are what are part of the restrictions that we have, as long as x is an element of what? Of integer values, right? So it could either be this, or we could not write that and write x such that x is less than -4, where x is an element of integers. Guys, I just wanted to bring that to your attention because, you know, it's an important thing and sometimes it comes up and it interferes with life. Okay, then the next two things that I want to just quickly do, between which two consecutive integers, this is a famous one, man. Between which two consecutive, I'm going to go into functions just now, okay, because allow me to start that at 9 o'clock, if you will. Between which two consecutive integers does the following irrational numbers lie? Thank you so much, Sekhameti, for the hot me. Thank you so much, really appreciate it. Hello. Okay, square root of 17. Okay, so obviously we're going to look for perfect squares on either side, right? Okay, I just want to quickly check this out. Square root of 17. So we like 17. We look for a perfect square number greater than 17. What is it, guys? Perfect square number that is smaller than 17 and a perfect square number that is greater than 17. Perfect square numbers are numbers that are formed by multiplying a natural number by itself. So can you guys give me perfect square numbers on either side of 17? One smaller immediately before 17 and one immediately bigger than 17. Perfect square numbers. Two perfect square numbers on either side. Can you give me such? So that I can put all of them under a square root and then get the two integer values between. So we have Sekhamete 16 and 25, Percy 16 and 25. Okay, we have 16 and 25. I think we can accept that, right? Smallest? Yes, princess. 16, 25. We can now put on the cloak of square rootness and do it for all the numbers. Then, of course, square root of 16 is 4. Square root of 25 is 5. Therefore, we can say the square root of 17 lies between 4 and 5. That's when we are given a positive number. Let's look at another one. What about negative? Okay, the square root of 23, that is negative. Okay, Okay, so with a negative number, we must be careful because we know that, all right, what is 23? It's a matter of looking for the biggest perfect square number that lies on this side of 23. The smallest, biggest, smallest, biggest, smallest, biggest perfect square number. So the perfect square number that comes after 23, the perfect square number that comes before 23. We do that because of the negative sign. Okay, we do that because of the negative sign, because you know, with the list of negative numbers, guys, negative numbers like -5, -4, -3, -2. So if you ignore the signs of negative, you are seeing 4 and 5. 5 is on the other side. Hence, when we are dealing with a negative root, all right, we must be careful to write down the big number this side, the small number this side. Are you guys with me? Do you feel what I'm saying? I need you to feel what I'm saying, because you might run into the risk of writing the small number this side, the big number this side, and then you actually don't write your numbers in the right order because of the negative sign. So for negative numbers, take note of that. So if we put there, because this means 23, you know, then we put there 25 this side. Very good. Then we put there 16 this side. So I'm very proud of you guys. 25 and 16, the way that you've written the order is what is making me happy. 25, you didn't say 16 and 25, you said 25 and 16. Now let's put on the cloak of negativeness. We put on the cloak of negative square root. Okay, it's like Superman. Put on our cloak, change everything. Square root of 25, -5. Okay, square root of 16, we have -4. This makes sense because the smallest number needs to be on the side, the biggest number must be on the side. Therefore, we say negative square root of 23 lies between -5 and -4. Now, I know some of you are like, yeah, I know this, Tisha, I know this. Okay, guys, I'm glad you do. I also wanted to just double check that you do. Okay, let's check this one out. Cube root of 16, between which two consecutive integers does the cube root of 16 lie? So now when we are dealing with a cube root, we are no longer looking for perfect squares, but now we are looking for what? Perfect cubes. And remember, perfect cube numbers, all right? Numbers that you multiply twice by themselves are your perfect cubes. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And so it goes, right? So the two numbers that are perfect cubes, that lie between, that lie on either side, okay, right, that lie on either side of cube root of 16, that lie on either side of cube root of 16. Yeah, you can see most, all right, that on this side. So if we write down 16, now we are looking for perfect cubes, not perfect squares, because if you write down a perfect square here, it does not accommodate the cube root of 16. So perfect cube that lies on this side of 16. So already you say, like I said, we have 1 and 8, we have 27. These are in consecutive order. So for 16, there's 8 and there's 27 on either side. Does that make sense, guys? There's 8 and there's 27 on either side. Okay, so 8 and 27. Then we put on the cloak of cube rootness. Okay, makes sense? Then we say, what is the cube root, all right, of 8? 2. 16. Cube root of 27, 3. Therefore, the cube root of 16 lies between who? 2 and 3. Makes life very easy there. All right. Yeah. All right. Then if you guys get something like this and they say between which two integers does 6 pi lie, hi guys, just grab your calculator. Grab your calculator and 6, shift, go to pi, the symbol, press it, and then you get 6 pi, you press equal, you press SD. 18,84. You have an idea what that number is. 18,84. All right. So then all you simply do is, since it's 18,84, it means 18, all right, is a number that is an integer that is on this side. So it has to be 18 and 19. So therefore all you do is you say 6 pi lies between 18 and 19, and that wouldn't be a problem, that wouldn't be a cinch. Okay, please guys, don't really waste your time here. It's just a matter of checking, right? Yeah. Then the other nice number thing that they like a lot is the one that says show that the recurring decimal, show that the recurring decimal. So let's say they say show that 0.864 with a comma at the, with a line above, a horizontal line. Does Casio have pi? Yeah, definitely does. Look. Here is pi. You just come here, you say shift, then you pi it. Okay, you shift pi, so you shift the pi. You shift pi it, my dear. Okay, you just say shift, then you come down here. There in yellow, there's Mr. Pi. Press there. Look, you see? It actually has a symbol there in your Casio calculator. Hope that makes sense. All right. Okay, guys, these ones are very important. These questions. Look who is recurring. The line, the horizontal line is above 4. So who is recurring? The 4. So we let x be equal to 8,6. That's equation 1. All right. Yeah. Then what do? We are going to multiply by powers of 10. So x, we first multiply by 10x. What does that do? It moves the comma how many times? Once to the right. So we now have 86, 4444. Right, that's equation 2. But if you look at this equation and that equation, are the numbers after the comma the same? Are the numbers after the comma? After the comma we have 644. After this comma we have only 4s. So far we have 2 equations and the numbers after the comma are not the same. So that means we need to then ramp it up and multiply the initial first equation, not by 10 this time, but by a power of 10, which is basically 10 to the power 2, which is 100. Doing that means that we move the comma 2 times. So we have now 864, comma what? 444. Do we now have equations that have the same number after the comma? Do we have equations that have the same comma and same numbers after the comma? Indeed we do. Do you see this? This is what we are wanting. Why do we want that? Because remember, a rational number is a number that can be written as a fraction. And the numerator and the denominator are integers. Okay? Where the numerator and the denominator are integers, but the denominator cannot be 0. So we can now say, let's take equation 3 and minus equation 2. Okay? Take equation 3 minus equation 2. Thank you, Mr. LL Mind, sir. Thank you for the heart me. Really appreciate it. Okay? Take equation 3. All right? We're going to take equation 3 and 2 because they have same numbers after the comma. Same numbers. That's what we want, because we want to eliminate or annihilate the decimals. They have the same number after the comma. Okay. Me, I just tell my learners to do this. You can formulate as many equations, just as long as you choose the 2 equations whereby you can actually do what? Okay, whereby you can actually subtract the same numbers after the comma. So now, what is 100x minus 10x? We get 90x, because we are taking equation 3 minus equation 2. 100x minus 10x gives us 90x. 864 minus 60. 864 minus 86. Guys, you tell me, what is 864 minus 86 so that I know what to write on my equation on the right hand side. What's 864 minus 86? 864 minus 86. 778. Thank you, Sekhamit. Really appreciate it. All the 4s, 4 minus 4, all the 4s will cancel each other, will have 0. So this is a integer value. The 90 there is an integer value. All we are left with now is to solve for x. We divide by the coefficient of x, which is 90 on the left. But what we do on the left, we do where, guys? On the right. Then we grab Mr. Calculator so that our answer, we can write it as a simplified fraction if simplification happens. So 778, we divide by what? By 90. We say equal. Look at the calculator, what it gives us. It gives us 389 over 45, which is what we want. We want the fraction to be simplified. 389 over 45. Please, guys, these are nice marks. Chowable marks. Don't allow yourself to not chow those marks when they are chowable. Okay. Make sense, ne? Don't allow yourself to not chow the marks when the marks are chowable. What? Okay. Let me conclude on this fashion with numbers, the number system, and then I will definitely be going to functions. Because, guys, I'm not going to really do the equations, solving, fractions, because I've been doing that. I've been doing that so many times in my live lessons, doing factorization equations, exponential equations. Like, I've been doing that. Unless there is a pressing question or something that you guys feel like in paper 1 you want to be covered, because I want to go to functions and I want to spend the balance of the time. I'm sleeping at 12 me today, all right? So from now until 12 I'll be doing functions all the way through, okay? But I just want to finish off this number system stuff. Look at this. For which values of x is an element of negative 10, minus 4 and 2 is this expression undefined? You guys tell me. Let me hear it from you. For which values of x is this expression undefined? There are your x values. They've given you a few there. For which values of x is an element of negative 10, minus 4, and 2 in curly brackets. So these are the only values that you need to consider. But for which values of x will the expression, this entire expression, the square root of 12 over 2 minus x, be undefined? Okay, can't see the denominator, it's 2 minus x. Yes, it's 2 minus x underneath the square root. So they're saying for which values of x is an element, negative 10 minus 4 minus 4, 2 is the expression undefined. Okay, Lesech was very fast off the blocks to answer that question. So it's when x is equal to, as you guys have said, 2. 100% correct. When x is 2. Okay, so if you say x is equal to 2, very good. Next question. For which values of x is the expression a rational number? For which values of x is the expression a rational number? Negative 10, minus 4, and 2. So if we take negative 4, what happens? What's the answer? If we take negative 10, what is the answer? We want to check the one that will give us a rational number. So I see the Lesech is saying negative 10 specifically. Okay, will give us a rational number. Sekhamit is saying both. Princess Kane is saying negative 10. Both what, Sekhamit? By both you mean which values? By both you mean which values? Negative 10 and negative 4. Okay, interesting. Interesting. Okay, interesting. I'm gonna check that out so let's check this. The square root of 12 over 2 minus x. Let's just check this out quickly. So if we substitute negative 10, that's 12 over 2 minus 10. Okay. Now we know a negative times a negative. 12 over 2 plus 10. That means 12 over 12. The square root of which 12 over 12 is 1. The square root of 1 is 1. So this does give us a rational number, no doubt, because 1 is a rational number. Let's check the negative 4, if it will work for the negative 4. 12 over 2 minus 4. All right, 2 minus 4. That's 12 over 2 plus 4. Okay, we together? That is 12 over 6. 12 divided by 6 is 2. The square root of 2, guys, is not rational. It is irrational. Okay, so the square root of 2 is irrational. Okay, so that means it's only when x is equal to negative 10 indeed that we get a rational number. So, but us substituting the last number helps us to understand, you know, how we were able to get an irrational number. It's when the x is equal to negative 4. So we have x is equal to 2 for an undefined, because we're talking about zero denominator, which we get when we substitute 2. X is equal to negative 10 for a rational number, because 1 can be written as a fraction where the numerator and the denominator are integers and the denominator cannot be 0. And then 1.1.3, when we substitute x is equal to negative 4, we get an irrational number. And I hope we are good. We are happy there. Okay. Guys, I don't know if there's any specific requests before I look at some function questions. Yeah, function questions. It's high time. The time has come. Alright, the time has come. Thank you so much for the finger heart. Sekhamid, really appreciate you. Thank you so much. The time for functions has come. Okay. The time for functions has come. Are you guys ready? Are you guys ready? Okay, you are. All right, let's look at this and look at it and unpack it piece by piece, line by line. The functions of m of x is equal to x squared minus 16. Let's first ask you guys, what type of function is this? M of x is equal to x squared minus 16. What is this function called? We call this function m of x. Specifically, what kind of function? mj is like, what's that? Which means mj has probably not done functions. Let me just check in the live how many of us are actually writing tomorrow and the functions are in the paper. Right. If you're writing tomorrow and functions are in the paper, please raise your hand, and maybe you can just comment further and let me know in this grade 10 paper that you'll be writing which functions will be tested. Is it parabola and straight line, or is it just all the functions, parabola, straight line, hyperbola, and the exponential as well? Is it all the functions that you guys will be tested on? So they said parabola and straight line. Okay, I see some are saying parabola and straight line. Yours are saying parabola and straight line. Parabola and straight line. Linear, only straight line. Percy is saying. Ooh, so that means some of you, I'm going to be giving you information that you don't need, because if some of you are saying only straight line, then it means here MJ is like, I don't know any of them. MJ, when are you writing? Okay, so guys, let me just allow me then. Okay, I suppose if the situation is relevant to you, then I guess you can be happy about it. But yeah, it's just that for this question, it's both functions on one set of x's. So I'm going to unpack it and help maybe even clarify for those that may know nothing at all. So the functions of m of x is equal to x squared minus 16, and p of x is equal to ax plus 2. Now, evidently, what type of function is this one? A of x plus 2. Seems like the value of a and the value of 2 we don't know, meaning the equation of that line we are still yet to find. The parabola's equation, though, is nice and defined, but this function's line is not yet nice and defined. We don't have the specifics of this function, but it is given in the form ax plus 2. So this is a linear function, or what we call a straight line function. So this is a parabola, guys, and this is a straight line function. Then they say the function of m, okay, m, I'm guessing they wanted to say the function of m and p. Okay, missing letter then. M and p. Remember, this is m of x and that's p of x. M of x is a parabola, p of x is a straight line. They intersect at G and E. The word intersect means they cross, cut, and overlap each other at G and E. So let's just check how true this is, because they are saying that both functions, they cross cut each other at G and E. Here is E, there is G. Indeed, these two functions actually do meet, cross, overlap, cut at E and G. And those are the only points where these two functions, they meet each other. They have a meeting, they have a relationship, they have something special happening at E and at G. All right, we call that the point where the functions m of x and p of x intersect. So formally, we usually call that the point E and the point G are called the point of intersection. What do we call them, guys? The point of intersection. That's where m of x is equal exactly to what? To p of x. The point of intersection. Okay? Where is it happening, this point of intersection? At G, which means there's an actual x or y coordinate that defines this point. And at E, there's a specific x and y coordinate, which is a point that defines that point as well. Are we together, guys? So far, are we fine? Can I just check on all of us? Are we fine? I almost feel like I need to invite a few people here. All right. So let's see. Let's get some people in here. It would be nice to talk about this. Have some other audible voices besides myself. Please, guys, if you guys want to come on up and have a conversation with me about this, so that we are clear as daylight, it would be nice to have a few people who would actually stand as representative. Let's get some people who are confident come up here. Even those who don't feel confident, you can come up here and we can talk about this function, so that if there's anything that someone else would want to ask in an audible voice, they can ask it for and on behalf of everyone else. Sometimes it takes a long time to type. So the functions will also show us how to find coordinates lengths, and others. Yes, I'm going to use I'm going to use this function to do a lot of things, Yosa. I'm going to even ask questions that are not in the question paper so that we can facilitate that kind of discussion. So whatever questions you may have in your head or things that you may be wondering about, be sure to type that question in the comment section, or at least you can request and we can discuss it further. We can talk about it more. But please, guys, don't come here and just, do funny stuff. Okay. Please, please, please. Otherwise, I will goodbye you very soon. Okay. Mnoto. Yeah, and if you don't speak, guys, I will actually let go of you if you don't say anything and you don't want to say nothing. Hello, Mnoto.
Hello, sir. How are you?
I'm very well, Mnoto, and you?
Yeah, I'm also fine, sir.
Does this name of yours suggest that you have money, my guy?
No.
Eh? Isn't Mnoto money? Yeah. So Mnoto, you are money.
Yes, you can say that.
You can say that. Oh, okay. So my guy, you are also writing tomorrow, or you're not?
No, I'm not writing, sir, tomorrow.
Okay. Then my question is, you are in grade 10, or you are in another grade? Because this is grade 10, my guy.
No, I'm doing grade 11, sir.
Yeah, my guy. Let me let you go, because this one is a grade 10 question. It's specific to grade 10.
Oh, yeah, that's not a problem.
Yeah. I'm sorry, man. Yeah. The thing is, guys, grade 11 functions, they operate in a different, they are similar but different. Because let me tell you one thing. Okay, I will say these things as we go along. But please, guys, let's have people. Don't be scared to come up. I would love to have a chit chat with you, and we can walk through these functions together. Okay, don't allow me to be alone, please. The K2 at M. Okay, I think K2 is very short to me. She's been invited up here. What's happening? Okay. Supreme Dad. This is a father. Daddy.
How are you, sir?
I'm good, Daddy, and how are you?
I'm good.
Okay, Daddy, are you in grade 10, Daddy?
Yes, I am.
Awesome. When are you writing?
Tomorrow.
Awesome, bro. Are you also writing on functions?
Yes, functions, factorization, and others. Yes, I am.
Okay, but like, have you done parabola, straight line? Up to what extent are you guys covering functions? Are you covering all the functions or just some of the functions?
I was supposed to cover all of them, but like I didn't understand most of them in class, so like I'm here to learn more about them.
Amen, my guy. Amen. Well, we are answering an exam type question now, all right? But
Yes.
as we answer the exam type question, I think those things that you may have had last time that was not nice, we can get clarity. When you can represent the rest of the kids that are here, and hopefully you will be given the knowledge to ask the questions that need to be asked so that we can get clarity on many aspects. So I'm going to start from the beginning. This question is saying the functions of m of x
Yes.
is equal to x squared minus 16. So we said that this type of function, x squared minus 16, is what kind of function?
You see parabola, I think. Wait.
Amen, my guy. Parabola, aka the quadratic function. That's
Yes.
another name. So a parabola, quadratic function, one in the same thing. Ne? You
Yes.
can see the form of the parabola. Thank you, Sefamit, for the rows. X squared minus 16 is the form. Ne?
Yes.
The equation is given to us. We are very happy. If we go to the graph itself, the Cartesian plane, okay, where the graph is drawn, here is the function. You see, happy as
Yes.
can be. Very happy, this one. Concave up. The letter M has been written to signify or denote the function. Okay.
Yes.
Then, and P of x is equal to AX plus 2 is drawn. P of x, here it is. But we do not have the value of who? Of A and Q.
Q.
Yeah, we don't have the equation of the function specifically yet, but the drawing is there. Ne?
Yes.
Then they say the function of M and P, meaning happy face, and P, the straight line, intersect at G. This word, to intersect, you understand what it is, Daddy?
Yeah, yes, it means meeting at a certain point.
Amen. Meeting at a certain point. Have you
Yes.
been meeting at a certain point with some people yourself lately?
No.
Oh, okay. So you are in isolation because you are studying, preparing for exams. Good for you. But do you know that we are intersecting at this point in time, Supreme Daddy?
Yes.
You and I are intersecting right now. Okay. Our point of intersection is TikTok, eh? Yeah. Anyways, let's go on. So the
Yes.
function of M and P intersect at G and E, ne? Then they say, so G, we can see there is
Yes.
G, and we can see there is E. Our G is in the
Yes.
fourth quadrant. G is in the fourth quadrant. We already can anticipate the kind of coordinates we are going to have here, because in the fourth quadrant, X is positive, whereas Y is negative. Okay. E
Yes.
lies on the X-axis. There's things that we know about the
Yes.
X-axis. And so that will help prepare us
Yes.
to know the
Negative side.
coordinates in the future. Right?
Yes. Yes.
Then as we continue, it says the function of P, meaning the straight line, intersects the y-axis at F. Where is F? There is F.
They're marked. Yes.
Yeah, 0 and negative 4. This
Yes.
0 represents the x coordinate. This negative 4 represents the y coordinate. And
Yes.
rightfully so, when the x coordinate is 0, we know that we are speaking about the y-axis. Because on the y-axis, the y-intercept is where we let x be what? Be 0. The y-intercept, when you want to find the y-intercept, we let x be equal to 0. So it makes sense that the x coordinate is 0. Then our
Yes, sir.
y value, the y coordinate, represents the y coordinate of the y-intercept. Okay? Let's move on. They then say AB. Where's AB? Here is AB. All right? This vertical line is parallel to GH. There is GH. And you have even written a perpendicular symbol there to show that the x-axis is perpendicular to this vertical line HG.
Yes.
And it is also parallel to the what? To the y-axis. So this line, and that line, they are all parallel lines. So then, after having seen
Yes.
all of this, we have questions that we are being asked. And the question is, the first one, determine the minimum value of m of x and hence the coordinates of C. The minimum value of who? Of m of x. And then they are saying hence the coordinates of C. So, how do we get the minimum value of this function, the parabola? Okay. Do you know? Do you have any idea, Supreme Daddy?
Not really, but let me see.
Sure. I will allow you to see. Okay. Minimum value of m of x.
As his wage says x, we're supposed to substitute x with a certain number, but the problem is the number should be a y value from the y axis, I'm sure.
It should be a y value from the y axis, you are saying.
Yeah, that's what I think.
Are you saying the answer to the minimum value should be a y value on the y axis? Is that what you are saying?
Wait.
So let me just share some information with you, ne?
Not sure, but I think so, because like I remember the yes.
Let me just share some information with you. Any parabola is given in the form y is equal to ax squared plus 2. A, which is the coefficient of x squared, if it is positive, we know that the function of the parabola is like this, ne?
Happy face, yes.
Yes, happy face. We call this concave up. And here, at the turning point, we have what we call the minimum value, which is the y value of the turning point. In other words, the y-intercept. Are you following?
Yes.
Yeah. And remember that the y-axis for your parabola in grade 10, your y-axis is a symmetrical line that cuts the function of the parabola into mirror images of each other. In other words, you can cut it symmetrically, so much so that the distance everywhere from this to any point on the parabola on the same horizontal line is always the same. So it's almost as if like this is the midpoint, all right, of the parabola everywhere on any horizontal line. Okay.
Yes.
Yeah. So if you want the minimum value, you must get the y value of the turning point, or in other words, the y-intercept. And how do you get the y-intercept of any function? You let who? X become what?
0.
Yeah. Are we together, my guy?
Yes. Can you please just give me 2 seconds to get my pen? This one stopped writing.
No problem. No problem. Go ahead. Okay. Just for the rest of everyone who's listening, if your function is concave down where a is less than 0, when a is less than 0, meaning this a value is less than 0, your function is, you guys learned happy and sad. Happy face, a greater than 0, meaning it's positive. Meaning you're positive, you are happy mode. A greater than 0, sad face. Alright, concave down. Okay.
Yeah, I'm back.
Yeah, no problem. So when a is, sorry, not greater than 0, when a is less than 0, you see now I'm writing something that's incorrect here, and I'm not even aware of it. So I said when a is greater than 0, concave up, your minimum you have the lowest, this parabola has a lowest value, the minimum value, which is basically it's cutting there at the turning point, the y-intercept of the turning point, y-coordinate of the turning point. If a is less than 0, okay, your function is concave down, set face, right?
Yes.
But this time around, what do we have? Not a minimum, but a what? A maximum. Highest value.
Yes.
Okay? Yeah. Because your y-axis is the symmetrical line as well. That basically, like I said, will give you that vertical line. Mirror image of each other. Okay? So we have a minimum, we have a maximum. So we go back to the question that they were asking you. Determine the minimum value of m of x. The minimum value of m of x. How do we get the minimum value of m of x? As we've just explained.
You said we need to find the y-interception, the y-interception at C, the y value.
So then what do we do in order to find the value of the y-intercept
We let
for
x
this function?
equal to 0.
Exactly. So you can go ahead and do that, and I'm sure you'll be able to get the answer. If you let x be equal to 0, then it means m of x, you are going to substitute in the place of x 0.
Yes.
So you're going to say m of 0, what was the function? Mx squared, mx is equal to x squared minus 16. So you substitute in the place of x your 0 value. 0 squared minus 16. So what do you get then as a value? 0 minus 16 is equal to negative 16. So that means m of 0 is equal to negative 16. This is the y-intercept of that parabola. So we can then say the minimum value is equal to negative 16. That's where we can first start, because they wanted us to determine the minimum value of m of x. So by letting x be equal to 0, that allows us to then find or identify the y value, the lowest y value that this function does reach, which is at this point the y-intercept. So there it is. Minimum value is equal to negative 16. They then said, hence, the coordinates of C. So when we write down the coordinates, who did we let x become?
0.
So that means our C coordinates are going to be 0 and what did y become after we substituted 0 into the function?
16. Negative
Sorry?
16. Negative 16.
Thank you. Thank you. That sign is very critical. Because imagine if you write that 16 and the negative is not there. That would mean that you basically lose marks unnecessarily. 1 mark gone because of a wrong sign for your coordinate. Okay. Supreme.
Yes.
Daddy,
Yes,
do you
sir.
have any questions about this that we've just done? Do you have any questions at all?
No, I now understand.
Yeah. So
The
if
minimum
they ask
part.
you, Supreme Daddy, for so this word minimum value, they can also say lowest value of the function, because
Yes.
minimum can mean lowest, or it can say
Yes.
smallest. I mean, these are just synonyms of the same thing. Okay. So the language may be different, but they are still asking the same thing. Determine the lowest value of m of x, or the smallest value of m of x. Any other synonymous word to indicate minimum can be used. Okay? Does it make sense? Then,
Yes.
secondly, if they say
Yes, sir.
hence, then it means use something of what you have done to then answer what are the coordinates of C. And you saw most how we went about doing that. We just simply got the x value that we substituted accompanied by the output value that we got of negative 16, which is the minimum. We wrote down the coordinates. No problem. Can we move on to the next question?
Yes.
Okay, the next question says, determine the length of ED. Where is ED? There.
Yes. E is there.
Yeah. So what kind of length is this? I'm asking you, what kind of length is it? Is it a horizontal length? Is it a vertical length? Is it maybe a other type of length?
It's horizontal.
Exactly. It is a horizontal length.
Yes.
And in order to get the distance of ED, since we know it's a horizontal length, we can use what we refer to as, whenever we want a horizontal length, we first need to have obviously the
X values and the Y values.
exactly. Yo, my guy, I think when you are with me here, 100%. We need the X values of E and D.
Yes.
Just the X values. We don't need the Y values. All right. Now, because it is a horizontal length, there's a formula most that we use for any horizontal length. If we want ED, the length, we are going to check who's on the left of this line. The left of this line, we have E, right?
Yes.
The right of this line, we have D. So when we want the length of ED, we say x right minus x at the left. So of course, who's the x that's on the right? It is D.
Yes.
X on the left is E. So we say x D minus xe. Now then, of course, our responsibility will be to find the x coordinate of E and the x coordinate of D. The question is, where is E and where is D on the function? I mean, on the Cartesian plane. E and D are where? What are they? What is E and D?
The horizontal line down they lie on the x-axis.
Very good. They lie on the x-axis. Is there a function that passes through E and D?
Yes.
Which one?
The concave function mx.
Very good. So the concave up function, the parabola,
Yes.
passes both through E and D. So as it decreases here, it passes through E. It turns. As it increases here, it passes through D. So it is the only function that passes through both E and D. The straight line also passes through E, but it does not pass through D. And we don't have the equation of the straight line. So we are going to use the parabola's function and get the coordinates at this point. Now you said something very important, Supreme, and that is E and D, they lie on the
x-axis.
Exactly. Whilst at the same time, the function of M passes through E and D and lie on the x-axis. So seeing as that's the case, the fact that E and D lies on the x-axis, that's a very important point. We're going to let what? What are we going to let? We're going to let y
be equal to
0, because the equation of the x-axis is y is equal to 0. Very important for you to know that.
Yes.
We let y be equal to 0. But since the function of the parabola passes through those points, we are going to let y be equal to 0 for m of x. Right?
Yes.
Yeah. So let's go and do that and find that. So we know m of x is equal to x squared minus 16. We substitute in the place of m of x 0, right?
Yes.
So 0 is equal to x squared minus 16. This sends us back to quadratic equations. The expression on the right is difference of
Squares.
2 squared. So then we factorize this. What does it give us?
X minus x plus 4 and x minus 4.
You are the man. You are the guy. You are the guy. And after that,
We're gonna say x is equal to positive 4 or x is equal to negative 4.
okay,
Sure.
awesome, 100%. Yeah, so for this bracket,
X,
we can say x
yes.
is equal to 4. For this bracket, we can say x is equal to negative 4. All right, then that means that we have the x values that we wanted. Definitely x d, the x on the right is the 4. The x of
Yes.
e is negative 4. And that's what we want so that we can now find the horizontal length of ED. So we take x on the right minus x on the left. X of D is 4. The formula that we have already has a minus sign. We put that in, and then x of E is negative 4. So we say minus
Negative 4.
minus 4, and then we say 4. What's a negative times a negative? Negative times a negative?
Positive.
So we have positive 4. So the answer
Positive.
then is 8. Exactly. So the answer then is ED is equal to what? 8 units. That is the length of ED.
Yes.
Okay. Are we together with this one as well? Kind of a bit of
Yes,
work
sir.
there. Yeah, because E and D are the main points that we need to focus on. Because we know E and D lie on the x-axis, as you explained, and they are forming a horizontal line. All we need are the x-coordinate of D and the x-coordinate of E. Y is the same, it's 0 throughout this x-axis, but our x values are different. Okay, so therefore we say x of D, once we get it after finding the x-intercept, letting y be equal to 0 for this function, we then are able to solve for x and get the x values. And it's as straightforward as that. That's how we are able to determine the length of ED. Okay. And the Supreme, personally, whenever I get things like coordinates and things,
Yes,
I
sir.
always update my diagram. The E I know now is negative 4 and 0. The coordinates of E are clear. It's negative 4 and 0. D is 4 and 0. And then obviously C I got as well. Initially 0 and negative 16. The next question that they are asking me is this one. And it is saying, determine the equation of P. P is what? It's the
P was
straight. It's the straight line, right? P of x. So now we are going back to grade 9, because it was in grade 9 that we started with linear functions. And then obviously here in this grade 10, we are just continuing with what we already knew, right? And just making sure that we are still clear about what we should know. So a straight line function, just want to give you a little bit of a kind of a summary, just like we did with the parabola. Straight line, most if you remember, y is equal to ax plus 2. Some of our friends here are familiar with y is equal to mx plus c. Thank you so much, KBM, for the donut. Really appreciate it. Oh my goodness, what a gift. Thank you. You're kind. So y is equal to ax plus 2, all right? Or some of our other friends are familiar with y is equal to mx plus c. Just remind us, Supreme Daddy, the a here speaks about what? What is this a?
A is our. That's our. What do they call it?
I think someone is going to type it for you if you don't say it first.
They.
Look at Andan. Andan just said something
I think it
in the
refers to
comment
the
section.
function we're talking about.
Zimfefe is also saying something. Zimfefe. Ayanda is also saying something. Andani, very true. We call that the gradient.
Gradient.
Yeah. Or some people say it's the slope. Okay. Because what does it do? It just measures how steep our line is, how close the line is to the y-axis. The closer the line is to the y-axis, the steeper it is. The further away our line is to the y-axis, the less steep the line is. Okay, so that's what gradient does. It just measures how steep your line is. Okay, if a is greater than 0, this is how your straight line should be, because it's positive, right? Increasing line. If a is less than 0, then your function should be decreasing. If a is equal to 0, we have a horizontal line. Y is constant. The y value is the same throughout this line. Just like your x-axis, it is a horizontal line. The equation of the x-axis is y is equal to 0. Does that make sense? So that's why we're saying that any horizontal line will have the equation y is equal to some constant value. Your x-axis has the equation y is equal to 0 because it is a horizontal line that has a gradient of 0. That's your x-axis, okay? Then you have a vertical line, black sheep of the family. It does not have the subject y in it. All of these are in this form, all of them, these ones. Because these three, okay, these three are truly functions. We call them functions indeed. This vertical line is actually not a function, all right? Even though, of course, we basically say a, or the gradient here, is what? Undefined. The gradient of the vertical line is not defined, it's undefined. Okay, and this vertical line will have the equation x is equal to some constant value. So your x value is constant throughout this vertical line, right? So these first three are what we call functions. Every x value produces a unique y value for 1, 2, the first two. A greater than 0, a less than 0. This one, we say it's a many to one function. Many different x values producing a single y value. So that's why we say these three are truly functions. But this one to many, not a function. It's not a function, this guy. Not a function. But, of course, that's why, for instance, you can see that these three, y is equal to is the subject. But this one, It's the black sheep of the family. When you write its equation, you say x is equal to whatever the constant value is throughout that vertical line. Okay. So Supreme Daddy, are you dadding with me with this linear function?
Yes, sir. Sir,
Yes.
I invited a few of my friends to the live, so like I'm gonna leave. I'll be back. There are a few things I have to do.
Oh, okay. Few things.
Yes.
No problem, my
Yes.
guy.
And
No
also,
problem.
if you are free, can you please send me the paper when you're done with it?
Oh, okay. No, I would be posting the paper after I'm done with it. Don't worry.
Okay, thank you, sir.
Yeah. This one is. I think a lot of people think that as I'm doing this paper, this is the paper that they'll be writing tomorrow. No, guys, I don't know what your paper is that you'll be writing tomorrow. I'm just doing a paper here to just expose you to some exam type questions. These are not all, they are just some. I don't have any idea what your paper will be like tomorrow. Have fun with it, by the way, if you are writing tomorrow. And please have the kindness to share the paper with me after you are done writing. Zimfefe.
Hi, sir.
Zimfefe. Wow, what a name. Only mercy, is it? Only mercy and all grace, eh?
Are you asking the meaning of my name?
Yeah.
It means mercy.
Yeah. Yo, it's too powerful, eh? You need mercy tomorrow, hey?
You are too. Since like
Yeah.
thing is, we were never taught functions, but then like we expected to write them. So I do this. At least I'm trying. I'm not over it.
Yeah, that's good. I'm happy you are trying. There's only one thing you can do. That is try, and you better do your try. You better try your darnest best, if you know what I mean.
Yeah, I believe you
And
can.
yeah. All right. So you've been following along as we've been busy here. I can see you've been commenting nicely there in the comment section. Just smooth commentary there.
Yes.
Yeah. So are you following? Are you with me with the straight line function? It's just repetition from last year. Are you in grade 10, right? Or
Yes, I am.
nice. So we are following with the linear function, no problem.
Yes.
Okay. Then the last thing I wanted to mention here is the Q value. This constant here. What does it represent?
Y
Zimfefe.
isn't the y-intercept?
Amen, Michael. Y-intercept. You are spot on. Remember, guys, this is a straight line function. We are not dealing with parabola because look at the x. It's in the numerator. The x has an exponent of 1. So this is a linear function, not a parabola. So we must be careful to identify the right function because linear function, x value in the numerator, no other x interfering. The exponent is 1 for linear. So you've rightfully said, Zimbev, that y-intercept, q means y-intercept. That's where we let x be equal to 0. We use that value basically as the y-coordinate of the function where it cuts the y-axis. So we are sweet. All right, we are good. I want to go back then to my question. Otherwise, so far, Z, I'll just call you that Z if you don't mind. So far, you've had no problem with this question that we answered here and this one. We can continue then.
Yeah, we can continue.
Okay, 5.3 then. I need your help because me, I'm shaky when it comes to these functions, but I believe you can help me out. How are we going to find the equation of P? This is the line P. And remember, we already have the coordinates of E. What are the coordinates of E again, Z?
Isn't it 4 and 0 or -4 and 0?
So the E, because it's on this side of the x-axis, we can confidently say it is?
Negative? I don't know.
Yes, negative?
4.
-4. And the y coordinate is?
0.
Exactly. So you're 100% correct there. Confidently say it, my dear young lady. Just say it confidently. You know your stuff. Don't allow the platform to intimidate you or anyone. You are good. You know your stuff. So on the negative side of the x-axis, the coordinates of E are -4 and 0, as you have said. Okay.
Yeah.
What other coordinates do we have on this line? Because what we want to do now is we already have the function p of x is equal to ax plus 2. All we want there is to find what, Z? What do we want to find in this equation? We want to find a and q. Okay, so we have the coordinates of E. What other coordinates do we have on this line, Z?
I don't know any other coordinates there.
So yeah, you see E, right? Do you see F? Just gonna go back here. We were told here the function of P intersects the y-axis at F, which is 0 and -4. Are you following, Z?
I'm following.
And here, look at F here. It's 0 and -4. F is on this y-axis. It's that point there. Okay?
Yes.
Okay. E, you already told me that the coordinates of E are what again, Z? Just remind me again so I can write them in pencil.
-4 and 0.
Thank you, Z. Man, where would I be without you there? There we go, -4 and 0. So now we want the equation of who? Of p of x. So you tell me, how would you go about it? Was in grade 9 you did it? If you have 2 points, the x
Actually, I
intercept
didn't
negative.
do it.
Sorry?
Actually, I didn't do it in grade 9.
Okay. Did you do it now in grade 10? In grade 10 then?
Not even.
Okay, now listen up. And tell me, are you writing tomorrow?
Yes.
And you'll be writing on functions as well.
Yes.
Okay, then listen up, and my dear. Ne? So you have p of x is equal to ax plus 2. I'm gonna show you 2 ways. The reason why there's 2 available ways to do to find the equation of this function is because if we are given the y-intercept, ne?
Yes.
If this is given to us, then there is something we already have already. P of x is equal to ax plus 2. This f, z is the y-intercept, the coordinates of the y-intercept. Remember, when you want to find the y-intercept, what do? You let x be what? Be 0, ne?
Yes.
Then you get a corresponding y value. This y value is actually the value of who, Z? Of 2. Are you with me?
Yes.
So what I can do is say p of x is equal to ax can stay for now because I don't know what the value of a is. But the plus 2 part, I'm going to substitute in the place of 2 -4. So a positive times a negative, what does it give me, Z?
Negative.
So I have -4. So I'm halfway there. I'm so halfway there. Like I have the y-intercept. So I can get a mark, and these people can say, "Ish, hi, he's there." 1 mark. Okay. So the clue here for Q is if you have coordinates of the y-intercept, then you can take the y value and substitute it in the place of Q. In grade 10, you can do that if you have the y-intercept. You can substitute the value of Q, which is this value -4, the y-coordinate of the y-intercept. Okay?
Yes.
There. Yeah. You can do it for the straight line. You can also do it for the parabola if you are told that this is a point that the parabola passes through. Okay. So both the parabola and the straight line, your y-intercept If it is given to you, you can immediately substitute the y-coordinate of the y-intercept. Your clue is if x is 0 and that point lies on the function, then it's given that this is your q value. Okay? Then we are not done. After finding the q value, we want to find a. So we can actually go ahead and substitute another point that the function or the straight line passes through. So f we've used. Now we can come to E and substitute the point in the place of y and x in the function. Z, p of x stands for what? What does p of x mean?
Why?
It means y, okay? That's the
Yes.
meaning. This is something that we call functional notation. It just means y. So I can just rewrite this as y is equal to ax minus 4. I am going to substitute e, the coordinates of e, which are negative 4 and 0. So x is negative 4, y is 0. So in the place of y, thank you so much, Stefan. In the place of y, I'm going to substitute who? Z?
0.
Yes. And in the place of x, I'm going to substitute?
Negative 4.
Yeah. And I do that for this substitution because it's multiplication in brackets. Okay?
Yes.
Then we are going to solve for who? For a.
Yeah. I was solving for A.
So a times. Sorry?
We're solving for A, right?
Yes. Why are we solving for a? Because we need him so that we can complete the equation of the function. Okay? So a times negative 4.
Negative 4A.
Yeah, minus 4. I'm sure this one is like a cinch. It's easy stuff for you. Linear equation. We transpose who?
Negative 4 to 4. Then negative 4 to positive 4.
So negative 4 becomes positive 4. Then we isolate. Okay?
Yes.
We divide both sides by,
Negative 4.
and then we get an answer of a is equal to.
Negative 1.
Now listen and check this out. This value, we can confirm if it is correct or not. How? Look at the direction and the shape of your straight line. It is a straight line that is decreasing. Okay? Y values are decreasing as you go down like this. Does that make sense?
It does.
Yeah. Therefore, if you look at what I said earlier on about the value of a, if a is positive, this is the direction of your line. If a is less than 0, this is the direction of your line. So if you look at the value of a, does it make sense that we got a which is negative 1 given the direction of the line?
Because it's decreasing.
Exactly. 100%. You got that one. Okay? So therefore we can then write the finale of the equation. P of x is equal to, we have a, we go and substitute in the place of a, negative x minus 4. Done. That is the equation of the straight line. Any questions?
Not any so far.
Okay, so what I'm saying then, Z, to you is that in the event that you have the y-intercept, you can go ahead and substitute the y-coordinate of the y-intercept in the function if you are looking for the equation of the function. Then 2, you'd substitute not that coordinate back into the function. You substitute another point that lies on that straight line. And then after substituting that point, you solve for who? For the last value, which is a. When you get it, sorry?
Why did we substitute E and not use 0 instead?
Yeah, The reason why we didn't is because 0 and negative 4, remember, we used the y-intercept, okay? Yeah, to basically get our Q value, which is from F. So we don't want to be redundant and use the same point. We use another point. Okay? So yeah, we use the other point to find the A value, okay? Or the other value of the expression or the function. Any other question you can ask if you like?
No other question.
Okay, so this is one of the ways. The other way, Z, you could have answered this question without even considering the whole idea of y-intercept, x-intercept. The minute, Z, you have 2 points, okay, 2 points, just 2, Z. If you have 2 points that lie on a line whose equation you want to find, okay, you can, if you want, for the straight line, first one, calculate what we call the gradient.
Yeah.
Have you ever seen this formula before? They usually use M to denote gradient. Huh?
Yes, we learned about it last year.
Yeah. So that gradient formula was used to find the equation of a straight line. Is that something they didn't do then with you? Because if you're saying they didn't do equation of a straight line, then but
Yes,
you did gradient.
thing is, I didn't use this formula for K10, but I used finding the equation of a line using this method.
Oh, okay. Yeah. Or alternatively, remember I'm just using A. Why am I using A? I'm just using A because it is the variable used as the coefficient of x. Okay? Yeah. So we could say maybe ye minus yf over x coordinate of e minus x coordinate of f. Yeah, all right. Just the order is important. You start with f, you end with e. You also start with f, you end with e. The order is important, okay? So the y coordinate of e, what's the y coordinate of e?
0.
It's 0. Then there's a minus sign in the formula, minus y coordinate of f.
You put in brackets.
Yes, thank you. Put in brackets,
Or you-
right?
Yeah.
Minus 4. Okay. Over x coordinate of e,
Negative 4.
and then minus x coordinate of f,
0.
0. At the top, what do we get?
4.
4. Okay, straight to the point. I love it. At the bottom, we get?
Negative 4.
Awesome. And then the final answer?
Negative 1.
Okay, you see, it does not deviate from what we had gotten here. Okay, so a is equal to negative 1. Even when we get the answer here, we're like, the straight line was a decreasing line. Does this answer make sense in light of the line? Yes, it does. I always like doing that for myself, because before teacher comes and checks my work, I need to have checked. I need to have avenues of checking if what I'm doing is correct, so that when I move on convinced that, you know what, I don't care what that guy or that woman does with my paper. He's gonna have a hard time trying to get marks away from me. All right. So, yeah. Okay. So you have A. Now you go there. You just say P of X is equal to negative what? X. Then you need the Q. Okay. If you have the knowledge of the y-intercept, then you go ahead, you just substitute that Q in the place of
Negative 4.
Okay. Yeah, you can just write the negative 4. Now, some people may not really like click with that. So some people, what they do, is they actually choose to substitute any of the points into the actual equation that you now have. So let's just say we decide to substitute E, which is -4 and 0, so that we can solve for A. Rather than do anything else, let us solve for A. So some people usually do that as well, which is fine. So this is the x and the y coordinate. X is -4, y is 0. So in the place of y, you are going to substitute 0. In the place of x, you are going to substitute -4. Then you find the value of q in this way. Negative times a negative. So that's +4 plus q. You transpose the 4 over.
-4.
Yeah, so therefore your q is -4. Then that gives you the power to then write down your equation. Remember, we need to write down the equation as p of x is equal to -x minus 4. Make sense? Yeah, so that's the equation of p of x. So I've just sort of like recapped 2 ways in which we can get the equation. Okay, because sometimes you may not get the 2 points being y-intercept. So if you don't have one of the points being a y-intercept, then it means you are going to have to use the gradient formula first and foremost, okay? Then after finding the gradient, you can then go ahead and substitute a point. After substituting the gradient, substitute a specific point, solve for q, and then get q, and then you get the function. Okay, does that make sense?
Yes.
Yeah. So that's
Wait. I actually have a
yeah.
question.
Yeah.
So you said before substituting now we can say that it is
Before?
-4 before substituting.
You mean for here?
No, that's the other side.
The other side? You said what?
You said we can use f like the -4. Wait.
Okay, say that again. I can't hear what you're
Said we
saying.
You said we can use -4.
Yeah, we can use -4 here.
So I would like supposed to use the y-intercept, which is a number, and not 0.
Yes, thank you so much. So here, the q value is exactly the y coordinate of the y-intercept. This is q. Q is this. This is q. Q is this, as long as your x is 0, and you know for a fact that this point lies on the function that you are trying to find. So you could have just gone ahead and done the substitution here at this stage. Final answer done. All right. I'm just exposing you to this as well so that you know that in some instances you may not have in your 2 points, with the other point being the y-intercept. So if you are just given 2 points, you can go ahead, use the gradient formula, find the gradient, and then you can use the point substituted, solve the equation, solve for q, and get the q value. Okay, and then get the equation of the line. Any further questions? Yeah, I almost feel like this is like, in and of itself, this is an act of mercy for you. Yeah, because you are the one that's saying that, like, you know, these straight line and stuff was not explained. So it's like, I don't know. I think you're ready. Yeah. Yo, mercy is upon you. That's for sure. Determine the length of OH. OH. Do you see the mark allocation for OH? So Zubair, I want us to check something out here. Let's take a walk around OH. Look at this. Where's O? There is O. Okay, O is the what is O? What do we refer to this as?
The y. I'm not sure. Actually.
So we call this the origin.
Oh,
We say this is the origin. Okay. And Madonzela is saying there the coordinates of the origin are 0 and 0. And he is very much correct. Ne? H, on the other hand, is on this vertical line. Right? Can I ask you, Z, on a vertical line, which value is the same on a vertical line? X or Y is the same on a vertical line. Which one is the same?
egg.
Sorry?
I don't know.
You don't know.
No.
Okay, so earlier on, I explained that any vertical line has what as being constant. What is the same along any vertical line? X is the same along a vertical line. Okay, I need you to understand that the value of X is the same everywhere along a vertical line. Right? For a horizontal line, who is the same along a horizontal line? Y is the same along a horizontal line. It's amazing that that fact is so important that if you don't really take it in, you see that 4 marks, it will say goodbye to you. All right. So, do you know what we need? We need to know we need to find the coordinates of G. What is G, Z? What did we say G is? G is the I said it earlier on. I said G is I said G and E are what we call the points of intersection. All right. And the last guy that was here, Mr. Daddy, said that it is where two functions meet. And I even made fun of him and I said, yeah, but anyways, let's forget about that. So the parabola here and the straight line, they meet at E and they meet at G. Do you see that? Yeah, where they meet. So where they meet, Z, do you know what we say? We can say there where they meet, M of X is equal to who, Z? P of X. Okay? Yeah. I don't know, I think there's like noise in the background. I'm having a tough time hearing you. Like, I don't know, when you speak, there's like a wooing sound.
Is it better now?
Yeah, it's semi-bad. Like,
Let me try it. I don't know.
yeah, okay. Anyways, so guys, point of intersection. At G and E, that's where the two functions, we say they are equal. So now we know that we already found that M of X we know that M of X is equal to X squared minus 16. P of X we know now is negative X minus 4. All right. So what we then do to apply this, all right, M of X is X squared minus 16. P of X is negative X minus 4. M of X is X squared minus 16. P of X is negative X minus 4. So what can we do now? We equate and solve this equation. It's as simple as that. Why? Because at G and at E, that is where these x squared and negative x minus 4, they are equal. Right? Okay, are you following here, Z?
Yes, I'm following.
Yeah. So we equate the substance x squared minus 16 because it represents m of x. The substance of p of x which is negative x minus 4 because it represents p of x. So point of intersection means m of x is equal to p of x. That's the equation. Now I'm sure you can solve this equation, Z. Do you want to just lead me to paradise it? Will you? So that I can get the x values. Then I can tie this back to what I was saying earlier on.
No, okay, I'm really thinking about factorization now.
Okay. So the equation, we need to first get it in standard form, right? We have x squared. Negative x needs to come on over plus x. Minus 16 is fine. We take the negative 4 over, plus 4 is equal to 0. Why are we doing this? Because we want to get the equation into the form ax squared plus bx plus c is equal to 0. We call this standard form, quadratic equation. Highest exponent of x is 2, right? X squared plus 6, what's negative 16 plus 4?
Negative 12.
Negative 12 is equal to 0. Then now we can factorize the trinomial. This is standard form for sure. Okay, x squared term, the x term, the constant term. Now we can do what? Factorize the trinomial. So Z, go ahead. Let me know what should we get inside the brackets then.
Wait, I'm trying to find.
Or are you trying to find? Okay.
I think someone should find first. 4 and 3.
4 and 3. How is the sign of 4? And how is the sign of 3?
4 minus 3.
Sorry?
4 minus 3.
So it's 4 and minus 3. Okay, very good. Okay, because the negative constant means different signs inside the bracket. But this middle term says the highest factor of your factors of 12 should be positive. I repeat, the negative constant means different signs. Difference means different signs. But this sign of the middle term says the highest factor is going to have the sign of the middle term. So that's why you see between 12, the factors of 12 are 4 and 3 that are useful for the addition that will give us 1. But the highest factor truly does have a positive sign. Then we write x and x here. We good, ne?
Yes.
This is factorized. Then we apply the zero factor law. This only applies when you have 0 on the other side. We take each bracket and equate it to 0. Okay. Then final answer, we solve the linear equation. What do we get? So this is the zero factor law.
X equals to negative 4. X equals to 3.
Now Z, let's quickly check something. You see these answers that you got? Look at them. X is equal to negative 4. Remember we said there are 2 places where your function has a point of intersection. At E, the function has a point of intersection. What is the x value there?
Negative 4.
Z, look at this. Negative 4. Do you see that? You see this answer? So this represents the x coordinate of E. And what is or supposed to be the x coordinate here of G?
Negative 3.
The x coordinate, Z.
Of
of G,
right.
your other value. Your other value. Remember, in this quadrant, your x values are positive, your y values are negative. So the x coordinate here should be 3, no doubt. Positive as well, 3. It makes sense. Does this x coordinate make sense? 100% it does. So don't be confused about what's happening in this quadrant. The x coordinate is 3. Are you with me, Z?
Yes.
Yeah, please. This is the x values on the x-axis. The y values. X is positive everywhere on this side. Y is negative. But we are not interested in y. We are interested in x because what did I say is the same, Z, on this vertical line? What did we say is the same?
You said X is the same.
Okay, but do you believe it now, Z? Or are you still sort of like accepting it by faith?
I thought.
You're just accepting it by faith.
Yes.
Yeah,
It's
so
like,
so
so
huh?
are you saying H is like like X coordinate is also going to be 3?
Yes, that's what I'm trying to say to you, Z.
Oh,
Yeah. Because Z, please get it into your mind, eh? And accept it with your heart, with a very open heart. I am saying to you, on a vertical line, if the line is vertical, Z, the x value on this line is the same everywhere, Z. Everywhere. Everywhere, Z.
yes.
Okay, so since here at G you have an x coordinate that's 3, do you know what the x coordinate of H is? It's also 3, Z.
Mm.
Are you with me?
Yes.
Yeah, right. So now I can come back because they wanted a Z. What did they want? They wanted the length of who, Z?
Oh, A.
OHZ. And here already I said, what is O? Do you remember what we said O is?
Yeah, I remember it's the same thing.
Yeah, it's the origin, right? And at the origin, or the center, if you want to call it that, because that's also fine, the x and y coordinate are 0. But remember, for a horizontal line, we said that we are only interested in what? If we want to calculate the horizontal line, the horizontal distance. Sorry?
Oh, wait, for the vertical X, I mean for Y. I mean, can you repeat the question?
I asked you for a horizontal distance, which values are we interested in using to calculate the horizontal distance?
What?
On a horizontal line, my dear. Remember, on this horizontal line, y is the same. So y is not going to help you with anything. So what are we interested in using to calculate the distance of OH?
X. X
Yeah,
coordinate.
the x values. So OH, so I'm going to say here, horizontal length. I need us to lock in, okay? Horizontal length, which is in this case OH. We say x on the right minus x on the left. Our x on the right for OH, the x that's on the right is the x value of H. So we say x value of H minus the x value of O, which is on the left. Okay? But because we know the x coordinate of G, we know that the coordinates of H are 3. And because h is on the x-axis, we know also the y-coordinate, it is 0. Okay, but now we're not interested in the whole point. We are interested in the x-coordinate of the point. X-coordinate of h, 3. The minus sign is there in the formula. X-coordinate of O is 0. What's 3 minus 0, Z?
3.
So we have OH, which is equal to 3 units. That is the horizontal distance of OH. I am happy now to take any of your questions, if you have any.
No, I don't have any questions. I think I'm just trying to process it because I'm learning all of this in one night.
Sorry?
Now I'm doing more than like processing it.
Oh, okay.
So,
I understand. Yeah, it's a pity that these meetings are happening only now and people are writing a day before. So where have you guys been when I've been doing live lessons?
so like I don't know. And I told my TikTok to notify me, so it's only been doing like grade 12 or grade 11 maths. And then there was this one time we doing grade 11 maths.
Okay. No, then that's fine. It's just that it's a pity, man. Like, I suppose that you probably would really be mastering this very well, because I can see you. I mean, when you know something, it seems like you know it and you know it well, right? So yeah, the length of OH is 3 units. Done and dusted. I don't know if there's any other people down there that have questions. Okay, but anyways, if not, then we can go on. 5.5, determine the length of OR. Okay, OR. Where is O? Here is O. Where is R? There is R. How many marks? 3. But then they are saying of OR, if AB is what? 18 units. Okay. Yeah, see, I feel like there's a lot you are going to be processing here. Because of the kinds of questions that are in this particular question paper. That's the thing, right? Yeah, and it's only because of the question papers, the questions that are in this particular question paper, this one that I'm doing. Okay, so you can see if we had the x coordinate of R, game over. Because to calculate the distance of ORZ, we just need the x coordinate of R minus the x coordinate of O. Because any horizontal length, we are always saying x on the right minus x on the left. Ne? Yeah. Now, we are told AB is equal to 18 and we are asked to determine the length of OR. So here's the thing, here's the logic that we use here. Do you see A is at the top? And you see on the same vertical line, B is at the bottom. Yeah. So when we are finding a vertical distance, it's like if, for instance, Z, there was a question that had asked, what is the distance of OF? Can you tell me what would be the distance of OF? O is 0, 0. F is 0 and negative 4. What would you have said is the length of OF? I'm asking you. O, and
Consider.
if I
So which one is considered right? I think it's negative 4.
the length of OF. Okay.
It's 0 because x and x are both 0.
Sorry?
Isn't it 0 because of both x and x are 0?
Okay. So remember, this time round, it's a vertical length, not a horizontal length.
So it's
So in a vertical line, who is the same? See?
x.
Yes, x is the same. You remember, I've been saying this to you. X is the same. So if you want to calculate the vertical length, are you going to use what is the same? No, you're not going to use what's the same. So we are going to be using who?
Wow.
Y, right? So we are going to say OF is equal to y at the top minus y at the bottom. The big numbers are at the top, the small numbers are at the bottom. So if you want the length, you have to say y at the top, y at the bottom. So for this OF, who is at the top? Is it O or F who is at the top?
Oh.
O. So we say y coordinate of O minus y coordinate of F. Are you with me?
Yes.
Then what's the y coordinate of O?
0.
0. You already have a minus sign in the formula. What's the y coordinate of F?
Negative 4.
Negative 4. So what's 0 minus minus 4?
4.
Which the answer then is? There we have it, see, it's 4 units. Remember, a distance, Z, can never be negative. You can't, when you are measuring a distance, even when you run, you don't say you ran a negative 100-meter race. No, there's no such thing. It's positive values. So your distance or your length has to be a positive value. So that's why I was fighting with you when you said negative 4. I was like, hey, bro, Z, are you sure? Can't be. Okay, can't be. Yeah, Sefamed, it's true. Even if you ran backwards, you still say you ran a distance of, and it's a positive value. Okay, so please. So for a vertical length, then I'm saying you say y top minus y bottom, because you are dealing with the y's for a vertical length. Because x's are the same, then you're dealing with y's to calculate the distance. If you are calculating a horizontal distance, you are dealing with the x's because the y's are the same. But remember, x right over x left. Okay. Yeah, if you use the distance formula mortar, you'll still get the same answer. But it's just that for functions, they have this recommended nice formula. I mean, you'd still be correct if you use the distance formula. There's someone who's asking if the distance formula wouldn't work as per analytical geometry. Yes, it would, definitely. Okay, any question there? This question was not in the question paper. I just decided to include it for the purpose of you understanding. Okay. Yeah. Okay. Any other questions maybe? Z? Okay. All right. Now I wanted to attend this one. All right. And then Yeah, I don't know, like if this is maybe a bit more on overdrive for you, Z, since like you're saying like there's a lot that you haven't, like it's just you trying to take in a bit. I don't want to obviously bombard you to the extent that, uh, but you will let me know most that that okay, I think I'm fine or what.
Yeah, it's okay.
Okay, so must I continue then?
Yes.
Okay. All right. So OR says determine the length of OR if AB is equal to 18 units. So OR, as I said, is this horizontal length. But the thing is, we don't have the x coordinate of R, not yet. But maybe we could find the x coordinate of A because it's in the same it's in the same vertical line. Or we could find the x coordinate of B since it's in the same vertical line because the x value on that vertical line would be the same. So because we've been told that AB is 18, we are going to say, well, which function is touching A? Because that's going to be our y at A because we don't have the specific coordinates. What is the function touching A?
M
It is the
M
m, the parabola, right? So we are going to say m of x, because that's y at the top. Then what is the function touching B?
P.
P. M of x minus P of x is equal to, we were told specifically that A, so that's why we take the function at the top minus B. Because B touches the straight line, we say minus P of x is equal to what, guys? Is equal to 18, because this is the distance using the functions now, the actual functions. AB, because A touches the parabola, we say m of x minus P of x. Why P of x? Because B touches the straight line, so minus P of x. We are told that distance is equal to 18. All right. Z, are you following here?
Yes.
What I'm doing here and why I'm doing it? Because I want to then substitute the substance x squared minus 16, which is m of x, minus x minus 4. Since there's a negative sign, we put the expression of two terms in brackets equal to 18. Okay?
Mm-hmm.
Then x squared minus 16, we distribute the negative sign inside the bracket. We get
Positive X.
positive x.
Yes, positive X.
We transpose the 18, becomes negative 18. Standard form again. X squared plus x. What is negative 16 minus 18 plus 4?
Negative 16.
Negative 16 minus 18 plus 4.
Negative 30.
Negative 30, which is equal to 0. Factors again.
Yeah.
Hmm? Yeah, I think we are like simultaneously revising equations by doing these questions, aren't we?
No. Then 5, 6 and 5.
6 and 5. The signs?
6 minus 6. Positive 6 and negative 5.
Positive 6 and negative 5. Is that correct?
Yes.
Very good. Then of course x and x, right?
Yeah.
So standard form, we got factors, we factorized. Zero factor law. Roots x is equal to negative 6 or x is equal to 5. Now, if you look at the two values, which one best represents the x coordinate of A, R, and B? Because the values we've gotten here, which one best represents the coordinates of A, R, and B given where x,
6.
which one?
Oh, 5. Positive.
Do you see that? Do you see that Z though? Like, as in like
It's 5.
proper.
Because, like, if x is positive that side.
Very good. Yeah, I see. I'm telling you, you like rivers of waters, man. Are we? Can I ask you this question, Z? Like, currently, like at school with maths, are we getting our nice marks? Like, or
Yes, I'd say so. Because recently, I wrote a trick test and yeah, I got 94%. So
yo, that's awesome. That's epic. Now I see. You've got those movings. You've got those. Yeah. Because I can see you catch on quite fast. Like if, like to be honest, sometimes it's this can be like pulling teeth. Yeah, I understand that. Like you said, there's just certain things that you like for the first time, but yeah, I must say I'm impressed that you're getting things so quickly. It's yeah, and you're following quite well. So if 90s is 90s, then you continue that same vein all the way through. It means that yeah, great stuff's coming up ahead then. Okay, then we know that the x coordinates, right, are all going to be 5. So that means our x coordinate of r, we now have it. You see? Because we wanted OR, so we now have the x coordinate of r. Okay. Yeah, that therefore means the x coordinate of r is actually 5. Okay, it's as straightforward as that. Now we want OR, so we know x on the right, which is xr, minus x on the left with it, which is x coordinate of O, is going to be 5 minus 0, which is 5 units. That's OR. So this is it's really like a question that needs you to really see that, okay, in instances where I'm not given the actual coordinates of points that are lying on a function, but I'm given the distance of that particular vertical line, then I can actually utilize the functions at that point and check who's at the top, who is at the bottom. Because y at the top, meaning the function, remember m of x means y. So m of x at the top minus p of x at the bottom gives you the sum of the length of the distance of AB, which is 18. And setting up this equation in this way was brilliant. M of x minus p of x is equal to 18. We then sub. Please, guys, when we substitute, make sure we put the expression of p of x, which is following a negative sign, in brackets. Because if you've simply put negative x minus 4, without considering the bracket. You may just multiply the negative with x, negative x alone, and then negative 4 gets compromised. And if it does, then that means you will be getting the incorrect value of x, which can be frustrating. So yeah, guys. Okay. Z is doing the most work. Really appreciate it. Okay, the next question says, what is the range of m? Do you know what range is when we're talking about a function?
Half maximum times minimum. Isn't it that?
Say that again.
Or is that applicable to half of maximum minus minimum?
Okay, so when you are thinking about amplitude in trig functions.
Or the maximum and the minimum is the range.
Sorry?
The maximum and the minimum, or the minimum to the maximum.
Minimum to the maximum. Okay, I like it that way. Minimum to the maximum. All right. So we usually say that range is the possible y values where your function exists. Range is the possible y values where your function exists, okay, or is defined. Okay. And when we write it down, we write it from the bottom to top. In actual fact, I like what you've just said because I've not quite worded it that way in the past, but I'm going to adopt what you said from now onwards. Minimum to max. Okay. Looking at your y values, of course. So m of x, where is m of x? This is m of x. Do you still remember what the minimum value was for m of x?
Yeah, I don't remember. But it was at the coordinates of C.
Yeah, but specifically, we said the minimum is equal to a specific value there. So out of those coordinates, which one did we use to judge the minimum? To make our decision about the minimum, did we use x or did we use y coordinate in this of C?
I don't know.
You don't remember?
No.
Okay, let me just page back so that I can remind you again. This was like smack bang at the beginning. Oh, sorry. Oh, we've been doing other things, haven't we? Grade 12s. Okay. Grade 12s probably hate me right now. Okay, here we were. If you remember, we let x be equal to 0. All right, x is equal to 0. We then got m0 is equal to negative 16. Then we concluded that the minimum value is equal to what? Yeah, negative 16. Okay. So it was the y coordinate. Because remember, even here now, we want the range. And the range is the possible y values where the function exists. So where does this function, this one, exist?
Where does it exist?
From where, minimum, to where? From where to where does the function exist? We start from the bottom, now we're here. Started from the bottom, now we're here. We start from the bottom, then we there.
It's A, isn't A?
Sorry?
Isn't like the top value A?
Say that again. I can't hear what you're saying.
Isn't the top value A?
Isn't the top value A?
Is
Why? What's A? I think you
like
mean like literally the letter A.
yes,
The
like
top
the
value. I'm a bit lost there. If you're saying the top value is A,
one at the
so
bottom is C. Like we use the Y coordinate of C.
that's very true. The bottom value is that negative 16. So you can write the answer in two ways. Okay. So from the bottom to the top. But is there a peak top that we reach, or is the function going to go on forever?
It's going on forever.
Exactly. Do you see these arrows? These guys. They are like, we are not stopping at all. Imagine if you would like literally right now, as you are seated wherever you are seated or lying wherever you are lying, imagine if you just started to float, like just off your bed right now. And then what would happen is that you continue like to do so like at a never ending rate, exceeding the boundaries of your house, going above and beyond the actual like earth that as you know it, going on to other planets and just going on and never stopping. That would be fun, right?
No.
No? Okay. I thought that would be fun for you, but I guess not.
Oh,
Okay,
yes.
so you can write this as y is greater than or equal to negative 16. That's one way of writing the answer. What does this mean? Y is greater means bigger than negative 16. Most negative 16 is your y value here at the bottom. Then you go on, meaning the function gets bigger than this value. It exists here at negative 16. That's why we say equal to negative 16. But greater than negative 16 also, gives us that idea that this function above negative 16 goes on. Okay? Or you can say y is an element of square brackets. Remember inequalities? Interval notation from negative 16 to infinity. Oh my word, this girl. Yo. Sorry for that, Z. Like, oh my goodness. This girl just never stops. Thank you so much, Shai Babylon. Really appreciate the hand heart. Yo, didn't expect that at all. Thank you so much. So kind. Thank you, Sekhamet. Thank you so much as well. I actually, sorry, oh my goodness, I've been so locked into what I'm doing here. But thank you guys. I really appreciate your kindness, your love, and just the generosity, man. It's just unheard. Like, Zimvefe. I mean, my goodness. Hi, Zizo. Z.
Are you closer?
Then she asks the question, are you closer? Hi, Zizo. Zizi.
Yeah.
Yeah, Ziz. Are you closer? Yeah,
Are you
I'm closer. I'm closer, cozy. You didn't pick it up from the,
I thought maybe like a lot of languages.
Yeah. I try. I'm trying with that one. Hey, that one of languages. Hey, I'm trying that one. Yo. We'll get there now. Yeah, but thank you so much, guys. Thank you so much, Shai and Sekhamet. You guys are too kind. Really appreciate you. Too much. grand supporters of these live lessons. It's insane. Like, the backing is amazing. Thank you. Right, guys? So Z, it is this. Y greater than or equal to negative 16, or Y is an element. Square brackets. Why are we squaring the brackets? Because negative 16 is included as our minimum value. The function touches negative 16 as the lowest point, so we are at the minimum. The bottom to top. Where to the top? To infinity and beyond. Buzz Lightyear stuff. Open brackets. So you can write this answer in interval notation, or you can write it as an inequality. Clear?
Yes.
Yeah. So that's range, see? Or sometimes they ask you for the domain. You know what the domain is, Z?
Really, I'm thinking about physics.
You're thinking of what?
I'm thinking about physics.
What is the domain in physical science term then? If you're thinking of physics right now.
Like when atoms, like they combine, like the fields of atoms combine.
Okay. Yeah. Domain is the possible. Now we switch variables. Possible x values where the function exists. Okay? Or is defined. So now we are just looking at x values. So this time round, we don't look from the bottom to the top, but we look from the left to the right. Because your left values are your minimum values and your right values are your max. So min to max. The min to max of domain is left to right, but the min to max of range is bottom to the top. Started from the bottom, now we're here, you know. All right. So ke ngoku if bunoyibhala i-domain Z, left to right, parabola vibes. Ne? The question is, does the parabola stop from left to right? Like you see, this, the function goes like this, but this arrow shows that it's been coming. It's been coming from the left. Forever it's been coming from the left. Then it goes, turns here, but then it goes on forever to the right. So forever from the left and forever from the right, what does that even mean if we are writing the domain? Do you know? Forever.
You're right, the
From the left.
maximum. Yes. The maximum is gonna be infinity.
Okay, and then the minimum?
The coordinates are E. X with negative 4.
Oh, so when you are saying the coordinates from E. No, Z. So remember, infinity and the negative infinity are not actually values in actual fact, right? Negative infinity and positive infinity. They're just showing you from the negative side, we are coming there forever from the negative. No end quite, no beginning and end quite. That's why we have open brackets. Like we count on forever from the left and from the right. So the domain can either be written as x is an element negative infinity to positive infinity. You see most these lazy 8s, the lazy 8 that are lying instead of standing up. Yeah, negative infinity to positive infinity, open bracket, that shows forever from the left, forever to the right. Or you can just write it as x is an element of what? Real numbers. Okay. So that's for parabola. Okay. Do you have any questions for me, Zee?
No, I'm thinking if I ask you this question, it's like way out of line. But it's still a function, but it's out of line.
These are out of line questions. Out of line questions are functional questions.
Okay, so I actually like this practice paper from my teacher. And like, I think this is a linear function. And for linear functions, I will mainly like just drawing the graph, like where we show x-intercepts and the y-intercepts and the top. Oh,
Yeah. And then also like finding that equation as you kind of saw there, finding the equation of that straight line. Yeah, so drawing, sketching, you need to know how to sketch, you need to know how to find the equation. You also, may need to identify the gradient from the equation sometimes. So they give you an equation of a straight line, they say identify the gradient.
so, to calculate the coordinates of a point in a like parabola, we first need to find the minimum values.
To calculate that, say that again.
To calculate the coordinates, like
So that you
choose.
can sketch it.
No, let's say we given the. Can I give you another example of a
Yeah, sure,
parabola?
go ahead. You can give me an example.
Yeah, it says yeah. Consider the parabola f of x equals to x negative x squared.
Okay, let's just say that. Consider the parabola
F of x
f of x, yes,
equals to negative x squared
negative x squared
plus 16.
plus 16.
Yeah, and then it says I must write down the coordinates of. Oh, it says with x-intercepts at points A and B on the x-axis.
Okay, x-intercepts
At
at point
A and
A
B
and B
on the x-axis.
on the x-axis, yes.
Yeah, that's it. And then the question that I asked is, it says write down the coordinates of A and B.
Write down coordinates of A and B, yeah?
Yes, that's the question.
Yeah, so let's see if you can answer the question. What do you think? So let's read the question again. It says f of x, consider the parabola f of x is equal to negative x squared plus 16. X-intercepts, the x-intercepts. What are these x-intercepts? That's where the function does what to the x-axis. This is where the function cuts the x-axis. That's the x-intercept at point A and B. Obviously, it will be at 2 points, A and B, on the what? On the x-axis. So there, on the x-axis, what do we know about the x-axis? What's the equation of the x-axis? We let...
Y equals to Z?
Yeah, exactly. We let y be equal to... Yeah. So I'm sure you can do that for this equation. And find the coordinates.
Should I find them?
Can you do it?
Well, I think let's do it.
Sorry?
Let's do it. Like, together.
So f of x is equal to 0, right?
Yes.
Because f of x, we remember, is y. F of x means y. So we can say f of x is equal to 0. Then that means negative x squared, which is represented by the function x squared plus 16 is equal to 0. Then we can solve. Divide by negative because it's a negative coefficient. x squared minus 16 is equal to 0. We divide by negative here, divide by negative there, divide by negative there. Gives us x squared minus 16 is equal to 0. Standard form. Factorize.
X minus 4 and x plus 1.
Yeah, you see. It's like we are going back into history. We just had something similar. Then
X equals to 4 or x equals to negative 4.
there we have it. And then the coordinates. What did we let first be? We let y be 0. So our coordinates will be
4 and 0 and then negative 4 and 0.
yeah, negative 4 and 0, 4 and 0. Then we can assign a and b respectively. So I don't know if they gave you a sketch for that function and they indicated a as your first point and b as your second point, or was it just a statement with a question in it?
A statement in it.
Okay, and they just said at point A and B. So I'm just taking the order A and B, the assumption being that A would be your negative and B would be your positive if we are following the order of letters. Okay, but I guess they would have to be more specific. Okay, so yeah. So very importantly is that whenever you're asked to find the x-intercept, you know that the x-intercept is where you let y be equal to 0. You substitute into the function and then you solve. Okay, so it doesn't yes Sekhamedzi, since they did not specify in her question, all right, it doesn't really matter. I think whether you'd say a is 4 and 0, b is negative 4 and 0, because they then become arbitrary, as you have said. What a word that you've used there. Yeah, but I just convention, since they say A and B, I'm just reading things from left to right. Okay, but they need to be specific in the exams. They can't be ambiguous as they are appearing to be as per this statement. They have to be specific. Okay, do you have any other questions that you personally have that like you feel like you need to get off your chest?
No.
Okay. All right. Okay. Then I don't know if you want to do these last two, the final concluding questions, or is this kind of like where you and I part ways?
I think let's switch on further more study functions.
Sorry.
Let's do it.
You want to do it? Okay. So I'm going to just conclude these last two. These last two then. Yeah. So this question says, look at people in the comment section. This is so funny. It's Raji is like saying, is it going to come out? Guys, yo, you guys are killing me, man. Killing me softly with your messengers. Okay, 5.7.1. Let me not get distracted. For which values of x is m of x greater than 0? Okay. When they say m of x greater than 0, remember, m of x is the function, but they are asking where is m of x having positive y values, because greater than 0 means positive, and it's specifically positive y values. Okay, stated differently, we are asking basically where is the function above the x-axis, because greater than 0 means above the x-axis, greater than 0. Okay, so they are asking where is this guy above the x-axis. So this is the x-axis. So they're asking where is the function above the x-axis. The x values that show the function being above the x-axis. They want the values of x which show the function being above the x-axis. So I'm going to show you where that is. You see this region? Look at the parabola. Here it is. It's above the x-axis. Look at this region. Here, the parabola is above the x-axis. But here, from here to there, the function is below the x-axis. So if you remember as well, I said, where is the y values for the function? What? Positive. So I usually like doing this I usually say this to my learners, that if you are looking at this function, the y values, as you're moving from left to right, look at what's happening. The y values here, how are they? All your y values here are positive. Then we get to the x-axis, y is 0. Then here, how are the y values? They are negative. Then we come here, it is 0 again. Then how are the y values here? They are positive. So what they wanted here is determine for which values of x is the function greater than 0. Is m of x, the parabola, greater than 0? In other words, where is the parabola positive? That's what they want.
Is it the same thing as asking where the function increases?
No, it's not. They're not saying where does the function increase. They are asking you where is the function positive. Where is the function having positive y values? Let's just put it that way. Where is the function having positive y values? So that's why I'm saying where is m of x having positive y values? Where is m of x having positive y values? Where is the function of the parabola having positive y values? So that's why I'm putting the plus signs here, because your y values here above the x-axis are always what, guys? They are positive. Are you with me, Zim? In there? Oh, I positive up, but positive up, up 0, up negative, up 0, up positive. Okay, so this is not the same question as asking where is the function increasing and decreasing. No, this is asking us directly, where is the y value for this function positive? Where is the y value for this function positive? If they had said m of x less than 0, then what would have this been asking?
The negative value.
Exactly. For who? For y, my dear, for y. But now what you have to do now is identify the values of x where you see this positive y, where you see this positive y. So what's important then is for you to have the x values for every x-intercept, y-intercept, and point of intersection. What am I saying? You must have every x value for the following: x-intercept, you must have that x value. Y-intercept, you must have that x value. And the point of intersection, you must have that x value. If you have the x values for these three, or for the other functions as well, you must have the x value of the vertical asymptote. If you have all of these, then it's good. When we deal with hyperbola and the exponential, you must also have the x values of the vertical asymptote. Okay, so Z, we are going to look specifically here at the x values, point of intersection, which is also the x-intercept, the y-intercept, all right, which is 0 for x, and then the point of intersection here, which is the x value is 3, and then the x-intercept here, which is, what did you say? Oh, it's positive 4. So now if you are writing your answer, okay, if you're writing your answer, where is the function positive? The x value where it starts being positive is where x is greater than 4. Greater than 4. Here at D, that's where x is great. When x is greater than 4, y is positive. When x is greater than 4. Are you with me, Z, about here when I'm saying x is greater than 4? Then y, you can see why as I move in this, as I go up like this, the direction I'm moving from 4 is in this direction. So as I move in this direction, there you can see my y values are positive. So my first answer is x is greater than 4. I don't put equal because if I put equal, I'm talking about on the x-axis. And on the x-axis, y is 0. Okay, they didn't ask for when it is equal to 0. They said greater than 0. Okay. So when x is greater than 4, y is positive for the function. Also, we come this side. When x is less than negative 4, meaning on this side of the function, y is positive. Those are your two answers. X greater than 4, x less than negative 4. X less than negative 4 or x greater than 4. That's how I would write my answer. I don't know if we are together, my.
We are.
Yeah, it's like fresh new stuff, right? It's like fresh out of the box, right? Okay, and then as I conclude the last question, yeah, because it was predominantly parabola and straight line that people mentioned, it's kind of like, that's why I decided to do a combined parabola and straight line. Okay, because I thought to myself, you know what, at least we'll be able to kill a lot of birds with one stone. If you look at this one, if they had asked for which values of x is m of x less than 0, then this time round we would have been interested as to, for this function, where is y negative? Y is negative between negative 4 and this 4. Negative 4 and 4. So if you write the answer, you can say x greater than negative 4 but less than 4. This would have been our answer that we could have written down to answer this question. Or we could write the answer in interval notation and say x is an element, negative 4 to 4, open brackets. That's also fine because it signifies between E and D. That's where we see y being what? Being negative. Between what? Between E and D. That's where y is negative. All right. So that's m of x less than 0 compared to m of x greater than 0. You are determining the values of x where you see this, meaning y, value of m of x is positive. Where do you see it? Left and right, where do you see it? You indicate. That's why the x-intercept, the y-intercept, and the point of intersection x value are important, because you usually use them to judge from left to right. Where do you see this? Where do you see this from left to right? Okay, let's do this last one. I think this is the one I'm going to go to bed having done, guys, for today. All right, remember that I do wake up in the morning, I think 5:30. I'll do a session 5:30 until 6:30 before I head off to work. just to sort of like maybe just send you guys off. I think I'll also. Sorry.
Which topic?
No, just like last revision stuff. Like I'll do random stuff. Paper one. Maybe I'll just get guest requests and ask people questions that they want to be answered on paper one. Otherwise, I won't be doing, because I know it's like tomorrow morning. Most people are just heading off to go and write their exam. A lot is in your head, and I don't want to be doing anything new. So I'm just gonna ask questions and answer questions for that hour.
From 5:30 to.
Yeah, just 5:30 to 6:30, because that's kind of shortly before I head off to work. I won't be able to really do a long, full-on session, if you want to know what I mean.
Yes.
Yeah, just touch-ups, touch-ups on any pressing things. Yeah, via TikTok, guys, via TikTok, not YouTube. Let me have mercy and do it via TikTok. Let me have mercy, because I am with mercy. Yeah. Okay, let's look at this one. This one, Z, it requires a little bit of interpretation. So let us understand that the function m of x is the parabola, right? But we are looking at his y value. The function p of x is the straight line, but we are looking at his y value. Okay? Then this dot, what does it mean, Z, the dot?
I know it from multiplication.
Sorry?
I don't know the functions, but I know it from multiplication.
Very good. It is multiplication.
Oh,
It's not changed. It's still the same thing. Now, I want you to look at this. What does less than 0 mean? Z?
negative.
Negative. So, the y value of m of x times the y value of p of x should give me something that is
Negative.
negative. The question is, what gives you something that is negative? If the y value of m of x is negative times the y value of p of x is positive, doesn't that give me a negative?
Yes.
Okay, then vice versa. If the y value of m of x is positive and then the y value of p of x is negative, doesn't that also give me a negative? So what I'm going to do then, I'm going to look for the intervals where this is true. So from left to right on my function, I'm going to look for the intervals where we have a negative for m of x, but at the same time we have a positive for p of x, because that should lead me to the answer of less than 0. Do you want me to repeat that one more time?
Yes.
So remember I said m of x, we're looking at the y value of m of x, okay? P of x, in this function, we are looking at the y value of p of x. Less than 0 means negative. Okay, that's the outcome of multiplying, because dot between m of x and p of x means the multiplication of the y values for m of x and p of x should give me something that is less than 0, meaning negative. Okay? That's this part. Y value of m of x, y value of p of x. The product should give me the outcome less than 0, which is negative. What gives me an outcome that is negative? That is if the y value of m of x is negative, whilst at the same time the y value of p of x is positive. That product of y values will give me a negative outcome. Or it can be the y value of m of x that's positive, whilst the y value of p of x is negative. The product will give me negative. Okay?
Yes.
So what I did already is I've already put plus signs, minus signs, plus signs for the parabola. The only thing that's left now is I need to do it for the straight line. So here, how is the straight line? Here.
Negative.
Here. For y, remember, we are talking for y.
Yes, okay.
Not for x, for y. Remember, that's why I said the y value of p and the y value of m.
The y is positive that side.
So here we are positive, right? At the top above the x-axis. Exactly on the point, it's 0. Here, how are we, the y value?
It's negative.
Yeah. And does it ever become positive again?
No.
No, it never does. It becomes negative all the way. So now, I'm going to move from left to right. And I'm going to check. So from negative infinity to negative 4. What is the situation from negative infinity to negative 4?
Positive.
Y of m is positive. Y of p is positive. The product gives us a positive. Do we have an answer from negative infinity to negative 4? Or in other words, where x is less than negative 4, do we have an answer of a negative outcome? Do we? Sorry?
No, the outcome is
No
positive.
answer. Yes, so there's no answer because a positive times a positive gives us a positive. So do you kind of catch a glimpse of what I mean by this thing? You first have to interpret this. M of x, it's y of m of x. P of x, it's y of p of x. Are we together? Then this here dictates the outcome of the product. Okay, because it's multiplication. Sometimes they will have m of x divided by p of x. That's division. So what you do with the signs when you multiply and what you do with the signs when you divide gives you the same outcome. Are you with me? Yeah. So if you are multiplying a negative and a negative, you'll get a positive. If you are dividing a positive with a positive, you'll still get a positive. So the signs, when you multiply or divide, will give you the same sign outcome. Okay. So we are seeing no answer for x is less than negative 4. Let's see now. What if x is equal to 4? What's happening at x is equal to negative 4. When x is equal to negative 4, what's happening to these functions? At x is equal to negative 4, y for m of x is 0, and y for p of x is 0. What is 0 times 0? Sorry?
0.
0. Now listen and check this very quickly. Remember here we had less than 0, but there was also a equal to 0. Okay. So equal to 0, we can only get equal to 0 if, let's say, maybe for y of m of x, it's positive, and y p of x is 0. Any positive times 0 is 0. Or when y of m of x is negative, and y of p of x is 0, negative times 0 is also 0. Or when y of m of x is 0, and y of p of x is 0, then 0 times 0 also gives us 0. or vice versa, guys. I'm sure you get the point. Okay. So we also check where we get 0. Now, I want to ask you, when x is equal to -4, don't we have a situation where the product of the y values for each function is 0?
Can you repeat?
I'm saying at this point, isn't the y value for our parabola 0, whilst at the same time the y value for the straight line at this point is also 0? And isn't then the multiplication of the y value for the parabola and the y value for the straight line at this point, isn't that going to give me 0 as a product?
I think so, because
Yeah,
0
it
times
definitely will, eh? It definitely will, because the y value for the straight line at E is 0. The y value for the parabola at E is also 0. 0 times 0 is 0. So x is equal to 4 is an answer that we can write alone. I repeat, x is equal to -4, sorry, not -4, is an answer we can write alone because it supports which condition? The condition of the product of y value of m and y value of p being 0, giving us 0, which is basically helping with the equal to 0 situation. Okay. I hope there's light there. You understand it a bit better. Okay, because yeah, we are comparing the y value of m and the y value of p. You know, the 0 of the y value of p and the 0 of the y value of m here at E give me a product of 0. And the product of 0 satisfies the inequalities condition, that if there's a product of these two functions giving us 0, then of course that's an answer. We have to say then x is equal to -4. Remember, we have no answer here from x less than -4. At -4 exactly, we have an answer. Okay, then we need to check further now. From -4 to 0, the y or the origin, -4 to 0. What is happening with the straight line? It is negative. How far is it negative? It's negative from here all the way to there. What's happening with the parabola? It's negative. It's negative from where to where? From E to D. Right? And what is a negative times another negative for this interval from E to D? What is a negative times a negative, guys?
positive.
Because this negative and this negative should give us a what?
Positive.
A positive. But that outcome, we don't want it. So there's no answer between E and D. Are we together? See?
Can you explain one more time?
Explain one more time. So the y value of p, z, is negative, right? The y values here are negative. The y values of the parabola from E all the way to D are also negative. So a negative times a negative for this interval will give me an outcome that is positive. Am I looking for that to get the answer here? No, because a negative times a negative doesn't qualify. So that means from this all the way to D, just before D, there's no answer. Now the question then is, what about at D? Is there an answer at D? This function is 0, whilst this one is negative. Does the product of 0 with a negative give us 0? 0 with a negative, does that give us 0? Yes. So that means we have another answer that is available where? At D. But let's check further so that we can see if we can't combine the answer. Okay. What if x is greater than 4 then? X is greater than 4. The y of m is positive, whilst the y of p is
Negative.
negative. Doesn't the product of these two give you a negative? Isn't that what we're looking for?
Yes.
Yes. So therefore the answer then there will be x is greater than or equal to 4. So our two answers fully then are x is equal to negative 4. That's just one answer that we get from the product of 0 and 0. And then the final answer, or x is greater than or equal to 4. Okay, that is basically how we answer those kinds of questions. Look at the y of one function, label where it's positive for y, where it's negative for y. Okay, and then you check where it's positive as well. And then you'll identify the intervals in accordance to the x-intercept, y-intercept, or the point of intersection. And you speak on those depending on the product of the signs you would want to achieve. Okay, and that's that. Okay, so I think I'm gonna stop right here myself. I think I need to, get some rest like all of y'all. Yeah, but Z, you've been a great sport. You've been an amazing sport. Like, I almost feel like if there was another reaction, then yeah, we would have the reaction. But you've been a great sport. Thank you so much. Phenomenal. Hopefully we run into each other again. It's been quite pleasant, and you've enjoyed the whole time. So yeah. Yeah, you can also thank your parents for actually allowing you. I mean, yeah, such a long time you've been on here. So yeah.
Okay, bye.
Sure, Z. Sure. All right. Yeah, guys. I think I'm feeling it myself now. I can sense a lot of people are tired. Like, it's been a long session. But thank you so much, guys. You've been great sports. And thank you again to my gifters. Like, guys, I can't stop thanking you. So thank you so much to my gifters. Like, you guys really make the day be a day. Thank you so much. Serhi, Moss, and also Shy Babylon. I know Shy Babylon is like long gone, but like, yeah, thank you so much. Sean, thank you so much. Otherwise, guys, let me love and leave you. I'll see you guys. Hopefully I'm able to wake up and push just one last time. Push one last time. Hopefully I'm able to wake up and can push one last time. Okay, hopefully it happens. Take care as well. Stay awesome. Thank you so much. Just want to. Yeah, there were some guest requests that I see here, but I just want to clear the air here. Okay, bye. I feel like some people are sleeping on their phones here. Let's see. Are you still awake? Are you really still awake? Like, are you for real awake, or is it just the phone dangling there? You just you kill me. No, it's fine. It's okay. I understand. You probably must be so tired. Oh man, that's funny though. I just woke up. Ah, my goodness. I think that TikTok laugh would be so amazing right now. Ah! No, 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 no. No, I'm just kidding, man. But yeah, you're killing me though. All right. Yeah, guys. Let me try and download this video and upload it there on the TikTok channel so that those who wanna watch, I mean the YouTube channel, so that those who wanna watch it, they can. It's so long though. It's so long. But yeah, thank you so much, guys. It was good. It was great. Lesego, when are you writing? When are you writing, my dear? Where are you writing? When are you writing? Guys, Lesego has a really big special place in my heart because you know when you birth something and you're writing tomorrow. Oh dear. YouTube channel link is in my bio, guys. Link is in my YouTube channel link is in the bio. It's called Maths is a Game. Maths is a Game. Maths is a Game. Link is in the bio. Yeah, so as I was saying, Lesego is a very special place in this dear little heart of mine. Cause yeah, she's like one of my children that they've been here for the longest. So I almost feel like she probably knows all my jokes. She knows all my jokes. She knows all the things that I commonly will say. I'm sure like she's so inundated with like everything and nothing surprises her. So I can imagine that sometimes it must be quite something. It must be quite an exercise to sit through a live lesson that I'm conducting and to think, man, I've heard this before. I know what he's gonna say. It's almost as if like I know what he's gonna say next. So yeah, I don't blame you. But yeah, everything of the best. I know you'll do wonders, Wonder Girl. You see, you're laughing because you know it's true. But yeah. Anyways, yeah, guys, it's been good. Let me try and download this thing. Yo, it takes ages though. Like from TikTok to download takes ages. Sometimes I literally sleep. There's people that have been like, download this, please upload this thing, and I sleep whilst I'm busy doing it because I'm like, yeah, it takes such a long time sometimes. But yeah, hopefully you watched all the others, like, yeah, because like I mean I've been doing videos and live lessons and all of that stuff, so I hope you like super legit prepared for tomorrow. But I believe in you. You'll do amazing. How up until how far? Let's say just before you bounce. Up until how far did you guys cover for the term? Like blankets are sealed. What is this? Up until how far did you guys cover? And when then are you writing paper two? Are you writing paper two on Monday? We did until graphs, just two graphs though. You mean you did up until straight line and parabola? Is that the two graphs you did? Okay, parabola and linear. Okay, that's kind. That is really kind. I understand. Okay. Parabola and linear. So basically your guys' test will be term one work on next week Friday. Thank goodness. Because I was like thinking you guys are gonna be writing on Friday tomorrow and then writing paper two on Monday. That would have been super crazy. So at least you guys have a full 1 week for that. Okay. Yeah, I'll be definitely doing some, yeah, because my intention was to actually start with trigonometry. So tell me, for paper two, content wise, have you covered trigonometry, analytical geometry, or what's the deal? Because what I'm planning to do is to actually start tomorrow with like your paper two topics. So what topics favorably would you like to sort of like hit the floor running with us doing, so that I can be sure to assist you there, or at least get things rolling there. I'm sure you've seen YouTube channel. I've there's a lot that I've uploaded here: geometry and analytical and the trigonometry series. Guys, there's a trigonometry series happening there, a lot. So you guys who have not subscribed to my YouTube channel, please go subscribe. Link is in my bio. And please, topics: trigonometry, Euclidean, and analytical, though we can revise. Yes, we've covered the 3 topics: trigonometry, Euclidean, and analytical, though we can use on trigonometry first. Okay. Yeah, so tomorrow we'll get the trigonometry afternoon. Okay. So we'll do between 6 and 8. 6 p.m. and 8. We'll do trig. And we'll do full on trig. We'll cover I'll just need to just make sure that we cover all the fundamental basics as per what you guys have been taught, so I can be sure that you guys are solid in the trig. Okay, then we'll take it one kind of step at a time. Or I might just start individual segments of each. Okay. Where does it go? Sleep. Sleep. You're making noise. You're making noise. All right, good night, guys. I'm gonna see you. See y'all tomorrow. I'm gone. Yo, 082. What's happening? Why is 082? What's up? Okay, good night, guys. Good night.